ASP.NET Core is one of the most popular frameworks for building web applications on the .NET platform. In this tutorial, I'll show you how to build a complete REST API step by step using ASP.NET Core and the C# language. Let's get started by taking a quick look at the topics that we'll cover across this tutorial. You will start by learning how to use ASP.NET Core and C# to create a REST API to manage the games catalog of a fictional game store. In this REST API, you will initially implement the traditional post, get, put, and delete operations with only a few lines of code. After the initial implementation, you will learn how to future-proof your API by incorporating several essential techniques like route groups, input validation, extension methods, and data transfer objects, as well as useful patterns like dependency injection, singleton, and repository. Then, you will stand up a SQL Server database in your box and you'll learn how to use the ASP.NET Core configuration system and the .NET Secret Manager to securely connect your REST API to the database. And following that, you will learn how to use the popular Entity Framework Core ORM framework to easily query and modify your database data using only the C# language. Finally, you will learn how to use the asynchronous programming model to improve the API performance and get it ready to scale. That will give you a solid understanding of how to get started building REST APIs with ASP.NET Core. If you want to go beyond the basics, please check out the link to the full course in the video description where I cover many other topics that will expand what you'll learn in this tutorial and will give you a full picture of everything needed to build a production-ready REST API with .NET. Next, we'll take a look at the finished REST API in action. Across this course, you will create the REST API for a fictional game store, and in particular for the games catalog section of that game store. So if we scroll down a little bit here, you're going to see that we have a bunch of endpoints to perform the typical CRUD operations for games management. So in this case, it would be an endpoint for getting all games, an endpoint for getting a game by ID, for creating a game, for updating a game, and also for deleting a game. And there's also an endpoint over here to upload the image that's going to be associated to each of the games. Now, of course, for each of these endpoints, you have a full description. Let's say we expand the put endpoint here. You get a full description of what this endpoint is for, what are the parameters supported by that endpoint, what is an example request body that you can send for that endpoint, and all of the expected responses that you can get from that endpoint, right? The same thing for all of the endpoints. And if you go all the way to the end, you're also going to see that we have the full list of all of the contracts or DTOs that are supported by this REST API. And one thing that you may notice here is that there is a mention of a version right here, right, V1 for one of the DTOs, and that is because this REST API actually supports multiple versions to allow for introducing new features without having to break our clients unnecessarily. So if you go all the way to the top, you're going to see that you can actually select up here, you can select between V1 or V2 of the API, right, where in V2 we have only implemented a couple of endpoints, but they return a different DTO, in this case with a different payload for the clients that are supporting that new version. Now, going back into V1, if you notice here, this REST API exposes its OpenAPI specification via this swagger.json file. If we click on that, this is the OpenAPI specification for the REST API, which allows any other kind of tool to easily start interacting with that API. And in fact, what I did is I just took this JSON here and I brought it into my Postman tool, which is a super popular tool for interacting with REST APIs. And after importing the REST API, I have the capability to start interacting with it in a very easy way. So for instance, if I wanted to go ahead and get all the games that have been created in my database, I'll click on the Get All Games endpoint over here, and then I can go ahead and click on Send, and that's going to go ahead and retrieve the games that are stored in the REST API, as you can see. Now, one thing to notice is that I'm not querying this in my local box. I'm actually going ahead and querying this directly from the Azure cloud, right? Because across this course, we want to show not just how you can create this API in your local box, but how you can interact with it and deploy it all the way into a production environment in the Azure cloud, right? So everything here is coming from the cloud. Now, in this endpoint, you can also do things like paging, right? So you can go ahead and just add a little parameter here to say, let's say I want to do a page size of 10, right? To get 10 games as opposed to the default 5 games. And so if I hit send, now I'm going to get a list of 10 games as opposed to the initial 5 that we had before. And we also support a feature of a search, right? So you can do now filter, and we can say, okay, so I want to filter and only get the racing games, right? As opposed to all the games. So I'm going to click on send, and this time I only get the racing games, Mario Kart 8 Deluxe and Forza Horizon 5, which are my racing games, right? So you can search either by the name of the game or by the genre of the game. And if I wanted to create a brand new game, I could go into the post endpoint over here to create a new game. And I'm going to expand this a little bit down here. So we have a payload here to create a Minecraft game. So I'm going to click on send. But what we're going to notice is that it doesn't succeed, right? We get 41 unauthorized. And that is because all of the endpoints that allow for any kind of modification of the data are protected, right? So they are behind the authorization and authentication features of ASP.NET Core. So you will not be able to just access that way. So in order to actually send the request, what we have to do is go into auth and we have to enable, let's go ahead and enable OAuth 2. And I have pre-configured a bunch of settings here. And so what I'm going to do is just get a brand new access token over here. And that is going to actually open up the page from the Auth0 service, which has been configured for this REST API. And I'm going to log in as the admin. Okay, so I'm going to log in. And after a successful login, I'm going to go ahead and receive my token. As you can see, here's the access token. And then I'll do use token so that we now have the ability to actually go ahead, and I'm going to hit send once again. And the game has been created. As you can see, that was a success. Okay, so across this course, we'll learn how to perform all of this integration to make sure that your API is fully secured. And of course, we could keep trying the different endpoints over here in Postman, but I think the best way to really show off what your REST API can do is by integrating it into a real and modern client UI, right? So that's why this course includes a ready-to-run client application that I can show you right now, and which is an application that you don't have to code. All you have to do is just download the source code that's included with the course, and you can go ahead and just run it, and it's ready to go ahead and connect to your .NET REST API. Now notice that this application is also running fully in the cloud. As you can see right here, this runs in the cloud so that you can get an idea of how to run both your client and your REST API end-to-end in a production environment. And of course, in this application, you can also see all of the features that we saw in the REST API also enabled here in terms of querying, right? So you can go ahead and do pagination. As you can see, you can go to page 2, page 3, and here's the brand new Minecraft game that we just created via the REST API, which doesn't have an image just yet. And then we can go back to page 1. I could use this search box to just type here, let's say Final Fantasy. That's going to retrieve all of the Final Fantasy games from the REST API. Or if I wanted to just look for racing games, again, that's going to retrieve all of the games from the REST API that have the racing genre, right? And so let me clear those search filters. And of course, one feature that we seem to be missing here is the ability to modify this games catalog here. And that is because we have not yet logged in into the application. So let me go ahead and click in the login button in the top right over there. So I'll click on login, and that's going to once again pop up the Auth0 authentication page. So I'm going to log in as an admin. And after doing that, the client recognizes that I am an authenticated user and I have the correct role, an admin role, to be able to do these modifications. And as you can see now, we have a bunch of new elements showing off over there and also down here and down there, right? For each element, for each game, we can go ahead and do modifications. So now let's go ahead and, for instance, let's go ahead and create a brand new game. So let's say we're going to be creating the Super Mario Bros. 3 game, right? Which is going to be, and we can select here, of course, that is going to be kids and family. And let's scroll down, and the price is going to be $19.99. And the release date, it was 10/23/1988, so a while ago. And so here you can also go ahead and choose a file that you want to use as the image for this game, right? And so here's the game catalog that you're going to get also as part of the downloads for this course. So you can go ahead and select one of these images. I'm going to select the Super Mario Bros. 3 one, open, and this is going to go ahead and upload the image into the Azure storage service, right? And retrieve the actual URL back into your REST API, so that when you save the game, you now have, you see page 3 now, you can see that we have our Super Mario Bros. 3 game with its nice image right there. And of course, just like when you can create games, you can update your game. So for instance, let's say for Minecraft, we don't have an image there yet. So I'm going to click on the edit button right here. And I'm going to say that this is actually Minecraft for Nintendo Switch. And then we're going to say that we actually want to choose a file for it. So I'm going to click choose file. And then I'm going to select my Minecraft image over here, click open. Again, the image gets uploaded into the Azure storage service. And then I'm going to click on save. And if you go back to page 3, you're going to see that Minecraft now shows its nice image. And finally, you also have the ability to delete a game, right? So I'm going to go back to page 1. And if I didn't want to see anymore my Fortnite game over here, I'm going to click on delete. I'll say delete there. And now the game is deleted and it is replaced by a game from the next page. So now that you know what you're going to build in this course, let's talk about what you need to know before starting with the course topics. In order to take this course, you should have some basic knowledge of C#, Java, or a similar object-oriented language. You should also know the essentials of web development, and it would also help if you have some experience with relational databases. However, this is a beginner-level course, so you don't have to be an expert on any of these topics since we write every line of code from scratch and everything we do is explained in detail. Next, we'll go over the software prerequisites that you will need in your box to get started. In terms of the software prerequisites for this course, all the tools you'll use are cross-platform, so you can use any computer with Mac OS, Windows, or Linux as their operating system. You will also need to download and install the following: the .NET Software Development Kit, or SDK, which includes everything needed to build and run .NET applications; Docker Desktop, which you will use to run your database server; Postman, the popular API client that you will use to interact with your REST API; and Visual Studio Code, a lightweight but powerful source code editor that you will use to write, build, and debug your code. You could also use any other code editors if you prefer, but VS Code is your best choice to follow along step by step. Please make sure you download and install these tools in your box using the URLs on screen before starting the coding part of the course. In this lesson, you will get an overview of ASP.NET Core, why you want to use it, and the different types of applications that you can build with it. So, what is ASP.NET Core? Well, in simple terms, ASP.NET Core is a popular web development framework for building web apps on the .NET platform. ASP stands for Active Server Pages, which was Microsoft's first server-side scripting language and engine for dynamic web pages, and was released in December 1996. It was superseded by ASP.NET in January 2002 with the first version of the .NET framework, and several years later, around 2016, it was superseded again by ASP.NET Core, where Core mainly hints to the cross-platform capability of this web framework. Now, it would be good to also briefly mention what is the .NET platform and how it relates to ASP.NET Core. .NET is a free, cross-platform, open-source development platform for building many types of applications that go from apps for Windows desktops to web applications, cloud applications, mobile applications, games, apps for Internet of Things, and even apps designed for artificial intelligence scenarios. .NET is a unified platform that serves the needs of all app types to make it easy to reuse code across all of your apps. Now, in this course, you will focus only on ASP.NET Core, which stands for the web type of applications that you can create with the .NET platform. Now, how do you create ASP.NET Core applications? Well, you get to use a programming language, but that language is not really .NET or even ASP.NET Core. You get to choose between 3 languages to create your ASP.NET Core apps, which are C#, F#, and Visual Basic. But in this course, we will be using the most popular one, which is C#. When you install the .NET Software Development Kit, or SDK, you get access not just to these languages, but also to a series of tools that make it very easy to get started with the platform, even before choosing a code editor or IDE. You also get access to a Microsoft and community-supported set of libraries and packages that can quickly expand the functionalities of your app so you don't have to reinvent the wheel. There are many ways to deploy ASP.NET Core apps to make them available to your users, that go from simple Xcopy deployments to fully Dockerized deployments ready for the cloud. Your ASP.NET Core apps are cross-platform, meaning that the same code that you write once can run on Mac OS, Linux, and Windows. And it's all open source on GitHub. Along with .NET Core, it has thousands of contributions by hundreds of developers and companies, making it one of the fastest growing and loved projects on GitHub. We talked about the different kinds of applications that you can create with the .NET platform, but even with ASP.NET Core, there are also a few types of applications that you can create. On one side, you can create very rich, dynamic, and interactive web UIs or frontends with the extensive UI framework included in ASP.NET Core. But on the other side, you can also create many kinds of secure and powerful backend services that can provide data to the web UI or take care of long-running or compute-intensive scenarios that don't need any user interaction. Now, when you create web UIs with ASP.NET Core, you have the choice to create either server-rendered or client-rendered UIs. A server-rendered UI dynamically generates the HTML and CSS of the pages on the server in response to browser requests, so when the page arrives to the browser, it is ready to display. To create this type of apps, you can choose either ASP.NET's MVC framework, which uses the model view controller pattern, or the Razor Pages framework, which follows a page-based model. A client-rendered UI dynamically renders the UI elements on the client, directly updating the page you see in your browser as necessary. These type of UIs are also called single-page applications, or SPAs. since usually there's only one single page that is continuously updated as you interact with the site. ASP.NET Core includes a complete UI framework known as Blazor for building this type of application with C#, HTML, and CSS. There are also several choices for building backend services. Web Application Programming Interfaces, or Web APIs, are the most common form of backend services, given how easy it is to use them to query or send data from and to backend servers using the HTTP protocol. ASP.NET Core offers two approaches to creating APIs. Controller-based APIs, which use controller classes to handle API requests, and minimal APIs, which define endpoints with logical handlers in lambdas or methods. Besides Web APIs, you can also create real-time applications via SignalR to push content directly from the server to the client, or gRPC apps, which allow for high-performance remote procedure calls between clients or services, or even background worker services, which can perform tasks that usually require no user input, like long-running or compute-intensive operations, or even tasks that start based on some sort of external event. You could also create microservices, which are business-aligned, loosely coupled services that small and focused teams can build and deploy independently using one or more of the available backend service technologies I just mentioned. Now, in this course, we will focus only on backend development, and more specifically, we will only cover the creation of production-ready REST APIs using the minimal APIs approach, since it's the easiest way to get started with minimal code and configuration. In the next lesson, we will get our development environment ready to start creating ASP.NET Core applications. At this point, you should have already installed all the software prerequisites that I mentioned in previous lessons. If you have not done so already, please go back, install the prerequisites so that you're ready for what's coming next. Now here I am in Visual Studio Code, and the first thing that we're going to do is to just change a few settings so that our C# development experience becomes much better. So what I'm going to do is just go into File, and then let's scroll down into Preferences and then Settings. And here we're going to be looking for a setting called Place Open Brace. And the settings we're looking for are Place Open Brace on new line for control blocks and Place Open Brace on new line for functions. So you want to tick both those settings, and that's going to allow us to make sure that anytime we create either an if-else or a switch or any of those control blocks, so that the curly brace starts in the next line. Same thing for functions, we want that curly brace to go to the next line. So this is more of a personal preference, but I find that it makes the code much easier to read. And the next setting that I want to enable is one called Format on Save. So you're looking at this setting over here, Format on Save, and you want to tick on that one. And this is going to allow us so that anytime we save a file, the editor itself is going to format that code so that it just looks better, right? So that's going to save us a little bit of keystrokes. Then what you want to do is go into File, and then you want to look at this setting over here called Autosave right there. Okay, so I'm going to go ahead and click on that one. And so with that one, what's going to happen is that anytime you make changes to your code files, those changes are going to be automatically saved into your machine without you having to save or hit Ctrl+S or anything like that. The code is just going to be auto-saved. So I find that also very useful as I go through the changes in my machine. So that's it in terms of our settings. And I'm going to close this and also close that. And the next thing that we're going to need is a couple of extensions. So if we go into the extensions hub right here, the extensions hub, click on that. The only extension that I have installed so far is this one called VS Code Icons. And I'm going to close this. VS Code Icons, which just gives some nice coloring into the file explorer in VS Code. But the one that we really need is this one called C#. And this is going to be the very first one, the one created by Microsoft, this one over here. You want to install this one, so just click on Install. All right, and that's going to install in just a few seconds. And this is going to bring in all of the C# productivity features enabled by the OmniShard server, which is an open source implementation that allows you to have really all sorts of IntelliSense and all sorts of nice productivity features of C# in your Visual Studio Code experience. Lastly, you also want to bring in another extension called C# extensions. Okay, and that's going to be this one over here. And notice that this is the one by Just Creative, right? There are a bunch of versions, but this is the one that you really want. and you want to just click on that and click on install. And this is going to add a few other context menus that are going to make it much easier to create C# files inside Visual Studio Code. So that's it in terms of the extensions, and I'm going to close this and close that. And the last thing that I'd like to do is just to verify that .NET has been properly installed into the box. So what I'm going to do is just go into my terminal by going into View, Terminal. And of course, you can also do this, if I close this, by just doing Ctrl+ on Windows, or you can also do Ctrl+J, which is my favorite shortcut. And in this terminal, all I have to do here to verify that .NET has been installed is just do .NET --info, and that's going to bring in all of the information about the version of .NET that you have installed. And as you can see, here's the version that I'm using right now. It's version 7.0.203. You don't have to install specifically that version. It doesn't have to be 7.0.203, but it has to be version 7, right? So you want to make sure that you're using version 7 of the .NET SDK. And that is because I will be using a few features that only showed up in .NET 7, right? So you need that version. And also you don't want to go a version above, like version 8 or anything like that, because the project templates that I'll be using in this course are based in the .NET SDK 7. And I'm not sure what kind of changes are going to come in those project templates in future versions, and that could make it so that you cannot follow what I'll be doing on screen the exact same way. So make sure that you have the .NET 7 SDK installed in your box. So with all this ready, let's move on into the next module where we're going to learn how to start creating our first .NET REST API. In this module, you will learn the basics of REST APIs and how to create your first REST API using the tools included with the .NET SDK. By the end of this module, you will have a solid understanding of the following: what is a REST API, how to identify resources in a REST API, how the different REST API HTTP methods work, how to create and configure a web API project in ASP.NET Core, how to implement a basic REST API with ASP.NET Core, and how to test your REST API using Postman. In this lesson, you will learn the essentials of web APIs in ASP.NET Core, how to identify resources in a REST API, and how the different HTTP methods work. So, what is an ASP.NET Core web API? Well, it turns to be that it is nothing more than a REST API implemented using ASP.NET Core. And your next obvious question is going to be, what is a REST API? To understand what a REST API is, start by thinking about all these apps that you have in your phone, like your weather app, Twitter, or Spotify. These apps use a ton of data, like the day's weather information, the top tweets of the last hour, or the hundreds of hours in your favorite playlists. However, that data can't live in your phone, which is what we know as a client, because it will be way too much data to store in your device, and you want fresh data all the time anyways. So the data has to come from somewhere, and that somewhere is going to be some sort of server computer that usually lives somewhere in the internet cloud. How can these apps talk to that server in the cloud to retrieve that data? Well, by using an API. API stands for Application Programming Interface, and is how a service defines the functions it provides to clients. So for instance, going back to the Spotify example, the Spotify Cloud Service could define an API with two functions: Get Recent Songs function that receives the username as a parameter and that returns the 10 most recent songs for the specified user. There could also be a Play Song function that receives the song name as a parameter and that returns the stream for that song so that a client can play it. Like this, there could be dozens or hundreds of other functions offered by the service that clients can use to interact with it. So an API helps clients communicate what they want to the service so it can understand and fulfill the request. So what is REST? REST stands for Representational State Transfer, and it defines a set of guiding principles that impose conditions on how an API should work. We won't dive into each of these principles in this course, but the important thing to know is that thanks to them, you can build APIs that are scalable, flexible, and independent of the technology being used in the client and in the server. So going back to the original question, a REST API or RESTful API is one that conforms to the REST architectural style. Now, the main reason why we want to stand up a REST API is so that our clients can interact with the data that it manages. But how do they actually reach that data? Well, for this, it is good to first understand the concept of a resource in a REST API. In a REST API, a resource is an object, document, or thing that the API can receive from or send to clients. For instance, in our game store application, the main resource is going to be our games. That's what clients want to query and modify. But in other applications, like the Spotify example, one of the resources could be the songs. And in the Twitter example, one resource could be the users, and another one the tweets themselves. These resources will be hosted on some domain, which could be a public domain, an intranet location, or it could be just your dev box. And they can be accessed either via the HTTP protocol or the HTTPS protocol, which is a must in public environments. So when you combine all of this, you get what we know as an Uniform Resource Identifier, or URI, and that is what your clients will use to identify and reach the resources on a REST API. There could be more parts to this URI, but these are the essential elements. Now, how do you actually interact with the REST API? Well, just like with traditional web pages, when clients want to request something from the servers, they will send an HTTP request using the resource URI to the server, and then the server will send back a response. However, in REST APIs, these requests and responses will look a bit different depending on the specific HTTP method used to call it. The most common methods are POST, which creates new resources, GET, which retrieves the representation or state of the resource, PUT, which updates an existing resource, and DELETE, which deletes the resource. So these methods allow you to create, read, update, and delete resources, and therefore they are also commonly known as CRUD operations. There are other methods too, but for the purposes of this course, we'll focus on these 4 ones. Let's take a quick look at each of these methods in the context of our game store example to understand better how they work. To request all games, a client will send GET request to the game's endpoint, and the server will respond with something like this. The first part of this response is the status, which is 200 OK in this case. This means that the operation was a success. There are many other HTTP status codes that a REST API will send back depending on the result of the operation, many of them for failure scenarios. The next part is the body, which contains the list of games in this case. Notice that this body is not HTML, which would be expected to render traditional web page. Here the format of this response is known as JSON, which stands for JavaScript Object Notation. This is the de facto format for sending and receiving data in REST APIs because of how easy it is to read and write and is supported by all major programming languages. If instead of getting all games you wanted to get a specific game, you would again send a GET request, but this time you would append the resource identifier at the end, number 1 in this case. The server will respond with the state of the game with that identifier, assuming it is able to find the game. To create a game, the client can send a POST request, once again using the game's resource URI, but this time it needs to specify the desired resource state in the body of the request, which in this example only includes the name of the game, but could include many other properties of course. The server will usually reply with a 201 created status code, and if the resource identifier was not specified as part of the request body, the response will usually include it. To update an existing game, the client sends a PUT request with the same resource URI as the one to get a game, but this time it includes the resource state, just like in the POST scenario. The server will completely replace the state of the game associated with the specified identifier with a new state and will typically respond only with a 204 no content status code. Finally, to delete an existing game, the client sends delete request to the URI that identifies the game to delete, and after deleting the resource, the server will usually respond with a 204 no content status code. So, in summary, your complete game's REST API would look something like this, and should offer all the support that your clients expect from a modern backend. Let's now jump back into the code to see how to implement this REST API in ASP.NET Core. So let's see how to go ahead and create our first .NET REST API. So here I'm back in Visual Studio Code, and the first thing that we're going to need is some sort of directory where we're going to be storing all of the files for the REST API. So what I'm going to do first is to just get rid of this welcome screen, and I'm actually going to click on this checkbox over here because we're not going to be needing this welcome screen anymore. I'll close on that. And then what I'm going to do is to open my terminal. And to open the terminal, what you can do is to go into View, Terminal, right? That's going to open it. Or you can also use a shortcut, like on Windows, you can do Ctrl+, or you can also do Ctrl+J to open and close your terminal. And now we are in the terminal, I'm going to go ahead and just switch into my D drive, and I'm going to go into my projects directory. And here I'm going to go ahead and just create a brand new directory that I'm going to be calling Game Store. Of course, you can create or use any other directory in your box. This is just the one that I chose for this course. And now that we have our Game Store directory created, let's go ahead and open it in Visual Studio Code. So I'm going to go into File, Open Folder, and then we can go into my D projects and then Game Store directory right here. And then I'll just click on Select Folder. and that's going to open Visual Studio Code in the context of the game store directory. Okay, so now it's the time to go ahead and create the project. So to do that, we're going to be using the .NET CLI in our terminal. So let me first collapse this pane for a moment, and then I'll open up my terminal using Ctrl-J. I'll open up this a bit more. And then to use the .NET CLI, all you have to do is just use .NET, and in this case, the new word over there. And then before we create the project, let me show you just a quick list of all of the project types that you can actually create here. So I'm going to say just list. And then, as you can see, this is a full list of all of the different project types that you can create with the .NET CLI. And that goes from ASP.NET Core projects, as you can see here. We also have some Blazor projects that you can create. You can create class libraries, you can create console apps, and you can create really a bunch of different types of projects. But the one that we're mostly interested in here is this very first one over here, ASP.NET Core empty application, we short name web, because that's the one that's going to provide us with a very clean slate to start very small with this web API, and we will start building up on top of that over and over across this course. All right, so let's use that template. So for that, let me just clean my screen, and I'm going to say .NET new web, and then we'll use the -n argument to specify the name for the project. So the name is going to be GameStore.api. Right? So I'll hit enter, and then the .NET SDK is going to go ahead and provision or create the project files for us. So if I now go, and let me just restore my terminal over here, go to Explorer, and if we expand on the left side, you're going to see that we have a bunch of new files just created. So let's take a quick look at each of these created files so that we get a better idea of what each file is for. So let me just close my terminal, and let's open up GameStore.api.csprog. So this file here is known as the project file. So you always have a project file, and this is the file that's going to describe what type of project this is. So in this case, as you can see here, this is going to be a web type of project, which makes sense because this is a web API. Okay, and then another important setting here is the target framework, which in this case it is Net 7.0. Okay, so this target framework defines which are going to be the set of APIs from the .NET SDK that are going to be available for your project or for your application, right? So since we didn't specify a specific version when we created the project, it just defaulted to the version of the SDK that we're using, which is .NET 7. I'm not going to go over the other contents of this file right now, but just know that there are going to be another important thing here is going to be the project dependencies that we're going to bring in later on, but we'll take a look at those when the time comes. Now, the next file that I'm going to look at is program.cs, and this file is known as the entry point of the application. Now, usually when you open up a C# file in Visual Studio Code, you're going to get this prompt over here, and what you want to do is just click on this yes button over there. Just click on yes, because that's going to go ahead and generate a brand new .vs Code folder over there, which we're going to be talking about in a moment. But it's very important to enable a nice building and debugging experience in Visual Studio Code. Now, also notice that as we open this program.cs file, the OmniSharp server was started, and you can tell it because of this little fire icon that you can see over there. Okay, that means that the OmniSharp server started, and like I said before, OmniSharp is the component of the C# extension that enables all of the nice C# features, IntelliSense, and a bunch of productivity features of C# inside the Visual Studio Code experience. So you want to make sure that you always have OmniSharp up and running in your C# projects. Now, if for any reason this VS Code folder did not get generated when you open the CS file over here, you can always generate it manually by just going to your command palette. So you can go into View, Command Palette, and then what you want to do is just look for this option called .NET Generate Assets for Build and Debug. So you click on that one, and then in this case, of course, it's going to ask me to replace what I have, but in your case, it can just go ahead and generate the files for you. Okay, so that's another way to get these things up and running. So I'm just going to hit cancel here. Now, what is going on with this program.cs file? Well, just a few important things. The first thing is that we're creating this object here that is a web application builder object, right, with this very first line. And this object is going to be used to define or to register a bunch of services and to configure a few things that are essential for your application. Right now, we don't have any services really to configure, so that's fine. But later on, you're going to see how we're going to be using it extensively to configure and to set up a bunch of services for the application. Now, the next line here uses that builder object to build what we know as the web application, and which is this app object over here. So that app object over there is the one that you're going to be using for defining the application pipeline. We're going to define multiple things, like for instance, the endpoints are going to be available in your REST API. As you can see, by default, we got one endpoint defined right here, right, which is going to be a get type of endpoint, so it responds to the get operation, and it's it's going to be mapping into the root of the application, and then this lambda here defines what's going to be the response when somebody invokes that endpoint. And we'll see this in action in the next lesson, but for now, just know that this is a very simple way of defining your initial endpoint there. And then the last line, app.run, just goes ahead and starts the execution or runs the application in the host, in the Kester host in your box, right? So that it can start serving requests. A couple of other files that we have available here are appsettings.json and appdevelopment.json. And these files are normally used to define a set of configurations that you don't want to hard code in your code files, right? So that way you can have different sets of configurations that can have different values depending on the environment where you're executing your application, right? For instance, appsettings.json is usually the one that's going to be available for the production application, but you can also have appsettings.development.json that's going to set specific values for your development environment. And you can see how we're defining logging here for the development environment, but we'll talk more about logging in a future model. Another important file here is going to be inside properties, launch settings.json, and this one defines what we know as profiles, right? That define a bunch of different settings that are going to be available for your application only where you're running in your development environment or in your dev box. For instance, this first section over here under profiles, this section here is known as the HTTP profile, and it's going to be the default profile that's going to be activated if you don't specify a specific profile. And this one is going to define a few things, but the most important one is going to be the application URL right here. So this is the URL that you can use in your box to access the REST API. Now that port number over there, 5115, got automatically or randomly generated for me as I created the project. So you're not going to get that same port usually. You'll likely get another port, but regardless, this is going to be the location of your application for HTTP purposes. Now, if you do want to use HTTPS in your box, you can also go ahead and use this other profile over here, the HTTPS profile. Right? So there are arguments in the .NET CLI you can use to start using that profile there. And as you can see, that defines an HTTPS URL that you can use to start using HTTPS instead of HTTP. Now in this course, we'll mostly be using HTTP. There are also some other settings for IIS, but we're not going to be using also IIS Express or IIS in this course at all. Now, we also saw that we got this VS Code folder generated on the left side. And so this folder has two files. The first file is named task.json, and this one defines how you're going to be building your project using the built-in tools of Visual Studio Code. And then we also have the launch.json file, which defines how is that Visual Studio Code can start and initiate a debugging session of your application within Visual Studio Code. And so now that we know what all of these files are for, in the next lesson, we're going to see how to build and run and also debug the application within Visual Studio Code. Let's see now how you can go ahead and build, run, and debug your application inside Visual Studio Code. So to build the application, what you can do is the following. Let me go ahead and open the terminal. I'll use Ctrl+J. So this opens my terminal, and I'm going to switch into my GameStore.api directory, okay, because that's where the files actually live. Now from here, all you have to do to build the project is just type .NET build, like that, and that will go ahead and build the project and produce the output DLL, as you can see right here. Here is the GameStore.api.dll generated, which you're going to find under bin, under the bin directory. You're going to find your DLL right there. Okay, so that represents the compiled version of your application. Now, in order to actually run the application, what you can do is the following. So let me clean this. You can go ahead and say .NET run, okay, hit enter, and that's going to spin up and start hosting the application locally in your box. And you can see that you also get your host and port right here. This is the host and port that you can use in your box to access the application. Okay, so what happens if we just navigate over there? So let me show you this. I'm going to just copy that URL and I go into my browser now. Over here, I'll just paste that, hit enter. And as you can see, we are getting our hello world displayed in this very empty web page. And this makes sense because if we go back into the code, you're going to remember that in program CS, what we have is just one endpoint over here that when you go into the root of the application, it responds with hello world, right? So that's what we have right now. But of course, we're going to be expanding this significantly to define our API later on. So that's kind of one way to do build and run of the application. Now, another way that you can actually build application, and let me close this for a moment, is by using the integrated Visual Studio Code experience. Since Visual Studio Code generated these launch.json and test.json files, right, what you can do is this. You can go into your menu bar, in this case, it showed 3 dots here because it's a bit smaller, but you want to look for the terminal menu in your bar, and then just go into Run Build Task or Ctrl+Shift+B. So you click on that, and that's going to go ahead and build your project directly using the Visual Studio menu. Now, because we can do this using the integrated build menu, it also means that we can just do Ctrl+Shift+B, as I just did, and then build directly. And all of that is enabled because of the task.json entry that you have defined over here. If you see in task.json, you have this build task defined over here. And because of that, you can do what I just did, right? So like I said, Ctrl+Shift+V will go ahead and build your project. Now, if you wanted to debug your application using Visual Studio Code and use breakpoints and stuff, what you can do is just let's go into program.cs for a moment, and let's put a breakpoint, let's say over here, okay? And let's see if we can hit it. Now, in order to start a debug session, what you want to do is go into this debug view over here, the debug view. So you click on that, and that's going to show you this pane over here, run and debug, where in this dropdown, you're going to see the different launch configurations that are defined in your launch.settings, launch.json file. So let's click on .NET Core Launch Web. And then what you can do, I'll just collapse this for a moment, and I'll click on the Start Debugging button over there. And what you're going to see is that the debug session actually starts. We hit the breakpoint right here, and you can even inspect the variables if you wanted to. And then, of course, you can step over and do the usual things. You can see the content of all the variables, and then you can just click on play so that this continues executing. And as you can see, this opened a browser window, right? With our hello world displayed right there, just as we saw before. So that's how you can debug your application inside Visual Studio Code. And like I said, and I'm going to stop this is enabled again because of the launch.json file that was defined when that was auto-generated by Visual Studio Code. Now, one thing that I'd like to change here is this one setting over here. And this is because this is setting that enables opening the browser anytime you start debugging, right? So if I just do like I just did, right, with the debug section here, or even with F5, I can just hit F5, right? And what's going to happen is that it's going to start application and it's going to hit breakpoint. I'm going to remove this breakpoint for a moment, hit play, and it's going to open yet another browser, right? So as you can see, this is going to get a little bit polluted with too many browser windows for our web API. And the thing is that you don't really use the browser to do any sort of testing of your web APIs. So this is really not needed. So what I'm going to do is just go back to Visual Studio Code. I'll stop this, close that, and then go back to launch.json. And what I'm going to do is just remove this section here that says server ready action, right? Because if you just remove this, the browser is no longer going to open anytime or every time you start a debugging session. So I'll hit F5 once again, F5, and this is indeed going to start the debugging session as it did, but it's not going to open a browser anymore, right? I find that super convenient because otherwise, like I said, you end up with so many browser windows. Most of the testing of the API is going to be happening in the Postman application, which we're going to take a look pretty soon. So now that we know how to build, run, and debug our application, let's go into the next lesson where we're going to learn how to define the entities that are going to be needed by our REST API. It's time to define the class that is going to represent the resources that our REST API is going to manage. So for that, what we're going to do is just right-click at the gamestore.api directory. So you just right-click there. We're going to say new folder, and then we're going to be typing entities. So here's where we're going to be defining our game entity, right? So the game is what defines the resources that are going to be managed by our game store API. Let's just go ahead and right click on entities and then new C# class. And the name of the class, like I said, is going to be game. Now, one thing that you can notice here is that the C# extension that I'm using in VS Code is actually defining the namespace as a block scope namespace, right? As you can see here, because of the curly braces that is here, so the class is inside the namespace. And that is okay, but I think these days a better way to do this is by using another thing called block scope namespaces, which saves a little bit of space on screen. So if you just step over anywhere in the namespace name over here and you click on this light bulb, what you're going to see is that you can select this option that says convert to file scope namespace. So if you just click on that, you're going to see that now the class is at the very, very left, right? And then the namespace has this semicolon on the end, right? So it's kind of the same thing, but now we're saving a little bit of horizontal space, which I think is a big saver, a small improvement, but a big saver in terms of horizontal space. And just like we did that, let's also go ahead and clean up a little bit these namespaces at the top. So what I'm going to do is, once again, you can just put your cursor anywhere in these namespaces here, click on the light bulb, and then you can select remove unnecessary usings. So I'll be doing this exercise of using file scope namespaces and just cleaning up the namespaces over there, just so we have a cleaner code overall. So now let's go ahead and define the actual properties of our game class. And the first property is going to be the ID. So let's define, and you can just type prop and then tab. That's going to define a property just like that. And then the type is going to be int. That makes sense. And then the name is going to be just ID. Right? So that defines our ID property. And let's go to the next one. This is going to be the name of the game. So again, just type prop, tab, and then this is going to of type string, and then it's going to be name. Now, one thing that you can notice here is that we have a small squiggle here with a warning, right? That what it's saying is that we have defined a property of a string type, but we have not set any value for that property, right? So what the compiler wants us to do here is to actually define some value for that string property, or define that the property is going to be nullable, right? So you could do something like this, right? Some value if you wanted to, like that, and that's going to satisfy the constraint. Or you could do something like string.empty there, right? Or if you wanted to keep it nullable because you're saying, well, it doesn't have to have a name, then you could just add this question mark over here, right? And that is going to turn it into a nullable, right? So the point here is that the compiler is trying to make sure that we don't end in a situation where we define a property that could be nullable, but we have not declared that it could be nullable, and later on we run into issues because of not defining this properly. Now, the thing about the name is that we don't want it to be nullable. We do want it to be a required parameter, right? It has to have a value. And these days, luckily, what we can do is just to define a keyword that allows you to specify that, yes, a value has to be specified for name, but we don't have to specify it right here in the definition. You just have to say that this property is required, just like this. Required. That means that whoever creates an instance of this game class has to specify a value for name, either in the constructor or as part of the property initialization when the variable is being declared. And yeah, it's a very handy feature, and we'll be using this required keyword quite a bit across this course. So now that we have a required, we have the name, let's go ahead and define prop string. This is going to be our genre, right? The game genre, and this should also be required. So let's do required. The next one is going to be the price. So this is going to be of type decimal. I think it's a good type for prices, for money. So let's just name it price. And the next one is going to be the release date. So whenever the game got actually released. So let's do prop. It's going to be date time. The name is going to be release date. And lastly, we're going to be adding a property here for the URL of the image that is associated to this game, right? The picture of the game. So let's do prop, and this is going to be string, and let's name it image URI. And then this should also be required. So let's do required just like the others. And so with that in place, we now have our game entity ready. And what we want to do now is to define some initial list of games that our REST API, which we're just going to start building in the next lesson, that the REST API can start using right away, right? So this, for now, this is going to be a list in memory, an in-memory list of games. And later on, we're going to transition into an actual database, right? So, but because right now the focus is on creating the API itself, let's just use a very simple list of games so that we have something to work with. So let's go into program.cs. And what we're going to do, and let me collapse this for a moment. What we're going to do is just to go to the very top And here we're going to be defining our list of games. So this is going to be list of game, just game. And then since we are introducing a type that lives now in a different namespace, right? So remember that game lives in game-store.api.entities. What we want to do is to introduce the namespace into program.cs. And to do that, what you can do is just step into or click into the game word over here. And you're going to see this light bulb over here. What you can do with that is show code actions, right? So you click on that. That's going to show a series of options that you can use to automatically make changes to your code. So in this case, we're interested in the using game-store.api.entities as you see here. So I'm going to click on that. And as you can see, that went ahead and right away added my using for game-store.api.entity. And then just so you know, another way to do this, and let me just do Control-C here. Another way to do this is just by, while you're in the word that has the curly braces, you can just do, at least on Windows, you can do Control dot, and that's going to, again, just pop up the dialog, and then you can click the option that makes sense. So like I said, in our case, it's using game-store.api.entities, and then we have our namespace right there. So I'll be using Control dot all over the place across this course. I find that that's the easiest way to do this. So with that in place, let's go ahead and say games. That's going to be the name of our list, and this is going to be new. And then let's define our list right away. So for our list, let's define our first game here. It's going to be new game. Right? And now let's define the values for the different properties. Let's also close these curly braces, just like that. So the first thing is going to be the ID. Okay, so let's just start with a simple number. ID is going to be 1. Then the name. For the name, I'm just going to pick one of my favorite games of all time, Street Fighter 2. And then for the genre, it's going to be, in this case, fighting. And then for the price, I'm going to say $19.99. Now, the thing about this number here, $19.99, is that it could map to different data types, right? Not just decimal. Now, our price is decimal, but since $19.99 could map to different types, the compiler gets a little bit confused here. So what you can do is just actually follow the guidance that you can see in the warning here. It says use an M to create a letter of this type, right? So you want to be explicit here saying that, yes, I do want to define a decimal and not just any other random type. So just by placing the M right here, you're clearly stating that this is a decimal, so that makes the compiler happy. And let's go ahead and say release date is going to be new date time. All right, so the date time for this one is going to be 1991/2/1. And lastly, we want to specify the image URI. Right now, what image URI we want to use here? Really, you could use really any image URI. It doesn't matter really too much at this point. But later on, when we get all the way to trying to show the games in the client, you may want to have something that just doesn't render a broken image or a random thing. Because of that, what I like to do is just use this very nice service that's called placeholder.co, which provides you with kind of a placeholder of an image of any size. So for instance, I can do the following: https placeholder.co/100. What that's going to do is to generate a simple placeholder of 100 by 100 pixels wherever you try to display the URL. So in fact, let me show you that. So I'm going to copy this. So let me just copy that, and I'm going to go into my browser very quickly here, and I'm going to paste it, and then I'll hit enter. And we're going to see, as you can see right here, is a super simple placeholder image for an image of type 100 by 100, right? And just like that, if you wanted to, you could go ahead and do another size, right? 200, or you could do 300 as you need. But I think 100 is good enough, right? So all it does is just provide us with some placeholder for the images, as like I said, that we're going to see later on in the client. So placeholder.co/100, you don't have to use it. You could use any other URL, but I just found it very handy. So just like we did that, let's go ahead and define just a couple of more games so that we have some data to work with in later lessons. So let me just copy this over here. And so this second game is going to be, let's scroll down a bit, ID2, and then I'll just put another of my favorite games here, Final Fantasy 14, and then this is going to be role-playing. And the price, this is more expensive, $59.99. Release date is a bit more recent, 2010, 930. And then for placeholder, for the image URI is going to be the same thing, right? There's no need to change that. And then let's add one last game here. Okay, let me scroll down again. So this is going to be ID number 3. The name of the game is going to be FIFA 23, very nice game. And then the type is, the genre is sports. The price is fairly expensive, $69.99, and the date time is much more recent, so 2022, 9 and 27. And for image array, we'll just keep the same thing. And so with that in place, now we have our game entity and we have our initial set of games, which, like I said, we're just going to do in memory for now. And later on, it's going to be an actual, it's actually going to be coming from a database. But for now, this is going to be great for us to move to the next lesson, where we're going to go ahead and implement our first API endpoint to retrieve the full list of existing games. Let's now go ahead and define the first endpoint for our REST API. And this is going to be the endpoint that's going to retrieve the full list of games. Here we're back in our program.cs file over here. And as you remember, we do have our in-memory list of games defined right there. And what I'm going to do is to just go ahead and collapse this just to save a little space on screen. And what we can do now is to just pretty much follow the lead of this initial get endpoint that has been defined here. And we're going to be reusing it to return our list of games. Now, like I mentioned before, there are a bunch of methods like this one here, map_get, that you can use to map different patterns into handlers that can take action whenever that pattern is invoked in a REST API. So just like map_get, if you do Control spacebar, you're going to see that there are a bunch of other options like map_post, map_put, map_patch, and map_delete and others, right? So let's go ahead and define our get. And the first parameter in here, like I said, is the pattern. So this is the pattern that has to be matched as a call from the client so that the handler can get activated. So in this case, it's going to be just the path, and the path that we're going to be using for our games REST API is going to be just games. Notice that I'm going to be using plural here, right? So games and not just game, because that is the correct way to define a RESTful API. So this is going to be defining the resources that are going to be managed by the API, right? And this is going to be games. So all of our calls are going to be starting with games, not just game, but games. And once we have the pattern, we want to define the handler. So this handler can take a few shapes, but it's really, in this case, it's just going to be a simple lambda expression that's going to be defining what we're going to return. So in our case, what we want to return is just this list of games that we have over there. So what we can do is just replace this with games. And just by doing that, you have already defined your very first endpoint for your REST API. Now let's see how this works. So I'm going to do Ctrl J to open my terminal over here. Okay, I'm going to be closing that and cleaning up this. And I'm just going to switch into gamestore.api, which is our actual directory. And I'm just going to type .NET Run. Okay, so this starts the API. And once again, it gives us the location of the API. In this case, it's localhost 5115. So I'm just going to copy that. And I'll paste that in my browser for now. So let me just go into my browser over here. So here's the local host and the port. But remember that we need to define here the full route into the REST API endpoint, right? So if you remember, the API endpoint is actually under /games. So I'm going to copy that because that's the part of the endpoint that we want to hit. And then back into the browser, I'll just paste that over here. And then I'll hit enter. And as you can see, we are getting now a representation, a JSON representation of the resources that the API is returning right there. You can see the list of games, right? So the 3 games are showing up right there. And that pretty much defines the result of our REST API invocation. Now, of course, looking at the REST API responses like this is not going to be very useful, as you can tell, and there are much better ways to do this. So in the next lesson, we're going to be learning how to use the Postman tool in order to properly query and work with our REST APIs. Let's see how we can use the Postman application to start working with our REST API. Now, the first screen that you're going to see usually when you start Postman is this one over here, which is asking you to either create a free account or to sign in into your Postman account. Now, if you wanted to, you could also go ahead and just click on this link over here to skip and go into the app directly. But I found that the experience is a little bit better when you actually have an account. So I would encourage you to go ahead and create a free account if you don't have one already. In my case, I already have one. So I'm just going to click on sign in over here, and that's going to take me into this tab over here. I'm going to just select my account here, and then I'll click open, and that's going to bring back the Postman application over here. as you can see, I am now into the Postman UI. Now in Postman, the main way that you're going to be tracking all of the things that you do in Postman is by using what they call as workspaces. So the workspace is the one thing that's going to keep track of a bunch of things that are kind of related. So for that, what I'm going to do is just go into workspaces over here at the top, just go into workspaces, and then I'll click on create workspace, and I'm going to create a workspace for the work that we're going to be doing across this course. So you could put any name here. I'm just going to put a name here named building.net REST APIs, right? Because that's the name of the course. And then I'll just click on this option here, personal. Okay, that should be good enough. And then I'll click on create workspace. And now we're here, we can go ahead and start creating requests, right? That's the main thing that you're going to be creating in Postman. So I'm going to just close this overview section here, and I'm going to click in this plus button right there. That's the one that you can use to start creating requests. So I'll click on that, and that's opening up this request over here. Now to save space, I'm going to collapse the left section like this, so that we can see better what's going on. Now, for some reason, it looks like the zoom is too much in this screen. So let me just go over here. I'll do view, and I'll do view zoom out. So yeah, now I can see much better. Now on this tab, what you want to do is first select the type of operation that you're going to invoke into the REST API. As you can see in this drop down, there are many different operations that you can use. But in our case, we're going to be starting with the get operation. So I'm going to just click on get. And then on the text box on the right side, you want to enter the URL to the endpoint that you're going to invoke. So let's remember what's going to be first the host and port that we want to invoke. So let's go back into Visual Studio Code over here. And then you can always find that by going into properties, launch settings.json, and in this case, it's going to be in the HTTP profile. That application URL is going to be right here. Okay, so I'm just going to copy this, localhost 5115. Okay, I'll copy that and paste it in the text box. And then remember that we have to specify the actual route into the game's endpoint. So once again, let's go back to VS Code. Let's go into program.cs, and remember that that's what we have in our map get. The endpoint is actually in /gains. So I'm going to copy that, and then I'll just paste that over here. Okay. Now let's also make sure that our REST API is actually running, right? So I'm going to go back into VS Code, Ctrl J to open my terminal. I'll clean this, and then I'll just do .NET run. Okay, so that starts the server, and now I can go back into Postman, and I'll just go ahead and click on this send button over here. So click on that, and that's going to send the request into the server. So I'll click on that, and as you can see down here, we got our results, right? So we have our 3 games, and this time things look way better, right? So it looks like proper indented JSON, right? That we can understand and that we can explore very nicely, and we can work with that later on. You will see as we move into the course that there are many utilities inside Postman that are going to be super valuable, and it makes way more sense to just work over here as opposed to working directly in the browser or somewhere else. So now that we know how to use Postman, let's move to the next lesson where we're going to learn how to create another get endpoint, but this time to retrieve a game by ID. Let's go ahead and define the endpoint to retrieve one game by its ID. So here we're back in our program.cs file, and then right here, just after our previous map-get call, we're going to be defining a new call to retrieve this game by ID. So let's just say app.mapget, okay? And in this case, the pattern is going to be very similar. So it's going to start with games as expected, but in this case, we have to add one more thing, which is going to be the ID. So the RESTful way to specify this is just by adding the ID at the end of the route. And then in the handler section, we're going to be defining how is that we're going to handle such a request. Now, the handler is going to be similar to the previous one, but in this case, we have to do more things, right? So we have to actually find that game before we can return it back into the client. So for that, the first thing that we're going to be needing is the parameter, the ID parameter. So for that, you can just go ahead and define a parameter just like this by opening and closing parentheses like that. And then we're going to be defining our int ID. Okay, now this ID variable name over here has to match the pattern that has been defined on the left side right here. So it says ID, it has to also be named ID as the parameter that we're going to be defining in the handler. Now here we're going to be defining an arrow function on the right side that's going to say that we're going to be returning the games, but then we're going to be executing the find function that's going to expect us to provide some predicate to match the actual game that we want to return. So here we're going to say, okay, so we want to find the game where game.id equals the ID that has been received as the parameter. Okay, then I'll just close semicolon like that. And that is the way that you can define your get by ID. And so let's go ahead and try this out and see how it works. So let's go ahead and do Ctrl J. I'm going to go ahead and do .NET run in the GameStore.api directory to start our server. And so let's go back into Postman. And what I'm going to do is just to copy this URL that I have here in my previous GET request. And I'm going to spin up a brand new tab over here. Again, with the get operation on the left side, I'll paste this, but this time I'm going to go ahead and add slash and the ID of one of our games. So if you go back into our previous list, we know that we have IDs 1, 2, and 3, right? So I'm going to go with ID number 1. So I'll just put 1 on the bar here, and then I click on send. And as you can see, that allowed us to return the specific game that we wanted to find. Also notice that we are getting the expected 200 result over here, 200 OK, which means that the request was successful. Now, one thing to consider here is what happens if somebody requests a game with an ID that does not actually exist, right? What would we do in that case? So let's see what happens right now. So in this case, I'm going to ask for a game with an ID of, let's say, 4, which does not exist. So I'll click on send, and then what happens? Well, we are getting a very strange null response over here, and for some reason we are still getting a 200 OK over here. So this is completely wrong, right? That's not what should be happening if we are not able to find the game. So to make this RESTful the right way, what we have to do is to figure out a way to return a not found result here in this case. Okay, so let's go back into Visual Studio Code, and I'm going to do Ctrl C to stop my server. And what we want to do is to expand this handler here a little bit more so that we can handle the case where the game does not exist. So I'm going to open curly braces over there and then close curly braces over here, just like this, perhaps. Okay. And then what we can do now is to actually capture the return of these games.find call. So I'm going to say, so game, which is going to be the game, is equals to games.find, and then I'm just going to close the semicolon over there. And then we are getting these curly braces here, this little warning here, because find is returning a nullable result, right? So we should fix this by saying not just game, but game with question mark, which turns game into a nullable value, right? So we could get a null here, so we have to handle that case properly. So now we're going to say, taking advantage of that nullable thingy, and I'm going to scroll down a little bit here, is the following. So we're going to say that if game is null, we are going to go ahead and return one specific result, and the right one for this one is going to be results.notfound. So that means we are not able to find that resource that you have requested. And otherwise, if we're able to find it, we keep going and we're going to say return results.ok. And in the parameter, we can specify the actual game that we want to return, which is the game. So now we're handling both cases, right? The not found and the successful case. So if we execute the API once again, I'm going to .NET run this again, and I'm going to go back into Postman. This time I'm going to ask for the game number 4 once again, and let's see what happens. Click send. And then, as expected, we are now getting a status 404 not found, which is correct. And if we go back and try to find an existing game, let's say game number 2, we should still be getting our 200 successful status like that. And we are getting, of course, the game on the left side. Okay, so that's how you should be handling those cases of the games that cannot be found. So with this in place, in the next lesson, we're going to see how we can create a request to actually create a game in our REST API. Let's now create the endpoint that's going to be in charge of creating games in our REST API. So for that, we're going to be scrolling down a little bit. Just after get, over here, we're going to be defining our brand new endpoint. And so it's going to be in a similar way. So app dot, but in this case, it's going to be a map post, right? So post is the right verb or operation that you want to use in order to create resources in the REST API. Now, once again, the pattern or the path is going to be very similar, right? It's going to be just games. And then for the request delegate or the handler, what you want to do is to specify here, of course, I mean, what's going to be the logic to create this game. but the parameter that you want to receive here is going to be the actual game, right? So for that, we're going to be adding just these parentheses here, and we're going to be defining our game like that. And then we define another function here where we're going to be defining what to do about that, right? And I'm going to be closing this with semicolon. I'm also going to be closing this to have more space on the screen. So how should we go ahead and proceed with creating the game? So the entire game payload is coming and in the game object over here, but what's not going to come is the ID of the game. So that will have to calculate here, just like as if a database would calculate that ID. So in our case, we're going to keep it very simple for now, and we're just going to say that game.id is going to be games.max, and that's going to be, we're going to try to get the maximum ID that we have so far, and we're just going to increment it by 1. So we're going to say max from the list of current games. We're going to say game.id. So give me the max, and then just add 1, right? Super simple. And after that, we're going to be adding that game into our games collection. So we're going to say games.add the game. All right. Let me scroll down a little bit more so we can see better. And lastly, we could go ahead and just say return. We could do a few things here. We could do results.OK. That would be one way to do this. But really, the right way to do this is to return a created result, so that you return back the created object and the location of that object inside your REST API. So to do that, what you want to do is the following. Instead of saying results.OK, we're going to be returning results.created@route. And so the first parameter here is going to be the name of the endpoint that can be used to locate a resource, right? So that endpoint for us is going to be this one over here. Remember, this is the endpoint that we can use to actually get one resource by ID. However, we have not provided a name for this endpoint just yet. So we need to do that. So what we're going to do is just expand this a little bit, right? The map get, we're going to say dot with name. And here we want to specify a name for our endpoint. And the name is going to be just, let's say, getGame. All right, and I'll close this. So that's how you can provide a name for one of your endpoints. Now, since we're going to be using that name in the other endpoint, likely we don't want to just hardcode this over here, but we actually want to have some sort of a variable for this. So I'm just going to copy this getGame name over there, and I'm going to go close to the very top over there, and I'm just going to define a constant to define this name here. So it's going to be const string. Let's name it getGame endpoint name, and that's going to be equals to getGame. All right, and then I'm going to copy that and then use it right here. And now that we have that available, we can scroll down once again into our map post, and for the first parameter of created@route, we're going to say that the route is going to be the one identified by getGame endpoint name, and the second parameter defines the route values. Remember that that route has to receive the ID, right? So it specifies an ID that has to be received here. So we have to provide that ID, and the way to do that over here is by just saying, creating kind of an anonymous type. So you can just say new, and here we're going to just define an ID, which is going to be coming from game.id, the ID that we just generated. All right, and for the last argument, we can provide the actual entire object that just got created into the REST API. So that's going to be just game, and closing semicolon. So by doing this, we're going to be creating a location header in the response after we have created the game into the REST API. So let's see how that actually works. So I'm going to open up my terminal. So Ctrl J, I'll do .NET run. Okay, and then let's go back into Postman. And this time we're going to be creating a post request. So let me just copy our endpoint over here. So I'll copy that. I'll click on the plus. And then let's switch this operation into post, and I'll paste the URL. And then this time we have to define an actual body, right? Because it's going to be a post request. So what you want to do is just go into this body section over here. So just go into body, and in body, you want to select raw. And in the right side over here, you want to select not text, but you want to select JSON, because we're going to be creating a JSON body. Now let me scroll down this here. And here's where we can specify the JSON representation of one new game. Now, to not type everything by hand, what I'm going to do is actually just copy the representation of one of the other games, the one that we retrieved in the previous lesson. So I'll copy that and I'll paste that over here. Now, like I said, we're not going to be providing the ID as part of the post request. That's going to be calculated directly by the API. So we're going to be removing this ID element over here. And then we're going to be filling in for all of the other elements, right? So let's go ahead and create our Minecraft game over there. And then the genre is going to be kids and family. And then for the price, it's going to be a bit cheaper. Let's say $19.99. And then the release date is going to be 2011. It's going to be 11 and 18. And then I don't think we need to specify a time for the release date. So we're just going to remove that piece. And then for the image URL, we just keep the same thing. So with that in place, and I'm going to expand this a little bit, let's go ahead and send a request and see what we get. So I'll click on send. And as you can see, and let me expand this a bit. As you can see, we are getting our expected 201 created status code. So that means that that was a success. The item was created in the API. We are also getting here a brand new ID for our created game. And of course, we have all of the rest of the payload of the game. But one very interesting thing is that we do have that header created for the location of our brand new resource. So if you go down into the console, so the console is going to be down here, the console. So this is always keeping track of what's going on with your request calls. So you just click on that one, you're going to see this, and then you're going to see at this point, I have one request for our get call, and then I also have one for our post call. So I'm going to go ahead and expand this. And if we go and look at the response headers down here, you're going to see that we have our location header, right? So that's a result of our use of the created@route method, right? So it calculated the correct location of the resource that just got created. So if we just copy that, for instance, you can just now copy that. You can go back into your getById endpoint over there. And I'm going to close the console for now. So I'll paste that over here. I'll click send. And now if we expand this, as you can see, we just got our Minecraft game using that endpoint that was provided by the post call. So that's a nice way to notify the client what is the location of the item that they just requested the creation for. So yeah, that's how you implement a post endpoint for a REST API in .NET. And in the next lesson, we'll see how to define an endpoint to perform updates to our existing resources. Let's now see how to define a put endpoint in our REST API so that we can update existing games. All right, so we're back into our program.cs file, and we're going to scroll down all the way to the end, just after the post endpoint over there. We're going to be defining one more endpoint, of course. So same idea, we're going to say app that, but in this case, it's going to be map put, right? And so the pattern here is going to be similar to the others, so games, but in this case, for a put operation, you have to specify what is going to be the ID of the resource that has to be updated. So for that, we're going to say just like this, ID, just like we did with the getById API. And then for the parameters we're going to receive in the second section, we want to specify two things. The first thing is going to be that very same ID, this ID that's over here has to be specified as a parameter. So I'll define int ID. And then the second parameter is going to be that updated game, right? So we're going to say game updated game, all right? And so just as before, we'll define our arrow function just like this, all right? And now comes the logic to find that game that has to be updated, right? So the very first section of this is going to be very, very similar to the section that we did for the getById endpoint. So I'm going to actually copy that section over here. So it's going to be this section here from getById. So I'll just copy that because it's the same idea. So scroll down here and I'll paste that right there. Okay, so we will go ahead and from our games collection, we're going to try to find the game. And if we cannot find it, we're going to say, well, the game is null. So we're going to be returning not found. And otherwise, we will proceed into the actual update of the game. Now, we're going to, just to keep things very clear, we're going to be renaming this game variable into existing game. And this, by the way, you can do by just typing, I'll do it again, just type F2 up on top of the variable, so F2, and then you can just say the new name for the variable. So existing game, and that's a nice way to rename variables across your code. All right, so now we just have to start updating all of the fields. So we're going to say existing game name equals updated game dot name, and then existing game dot genre equals updated game dot genre. Existing game dot price equals updated game dot price, and then existing game dot release date, and finally existing game dot image URI is updated game dot image URI. And then the correct result to return here from a put request is usually return results dot no content, right? You can also return an OK result, but the more traditional thing to return here is usually just no content. Now, one thing that I want to clarify here is this one here, right? So why are we returning not found, could we do something else here? Now, there is a line of thinking here that for a put endpoint in a REST API, what you really want to do is always create the resource if you cannot find it, right? So that would mean that in this case, if we cannot find the game, we just go ahead and create it, right? That way, the put endpoint is kind of idempotent, so it always returns the same thing, right? So it doesn't matter if it exists or not, we always end up with the resource created. Now, the reason why we're not going to be doing that, and instead we're just going to be returning a result not found, is because in our future implementation, when we introduce a database, specifically a SQL Server database, it is going to be the database the one that's going to be providing the IDs for the created resources. So in that case, if we received an ID over here for the put endpoint, and then we cannot find the element and we let SQL Server just go ahead and create the ID for a brand new element, likely that generated ID is not going to match the ID that the user provided, right? So if user provides ID 123, which does not exist, and then we go ahead and say, hey, SQL Server, generate an ID, SQL Server is going to generate some 456 ID that is not going to match what the user requested, and that's just not going to make any sense, right? So because of that restriction from SQL Server, which is going to be the one generating those IDs, we're going to go with this other way of implementing a put endpoint where if the game does not exist, we're just going to return not found, right? But like I said, there's that other line of thinking, so just keep that in mind as we move forward with this implementation. And so with this in place, we should be able to go ahead and try it out. So I'll open up my terminal once again, so Ctrl J, and I'll do .NET Run, and then I'll go back into Postman. And this time I'm going to be creating a brand new request, which is going to be with the put verb over there. And then the actual URL is going to be, like I said, very similar to the one for the get by ID. So I'm going to be copying it from our second tab for get by ID. I'll paste that over here. And now let's make sure we use first a game that actually exists, right? So if we go back into the get by ID, I think that we can go back into ID number 2 here. So I'll send that, but let's actually go back into ID number 1. ID number 1 is Street Fighter 2. So let's work with this one here. So for the put, we're going to be using ID number 1, and then you have to go into the body once again, select raw, select text, and select JSON. We want to do a JSON input over here, and then let's go ahead and just paste the same, pretty much the same value as in the get by ID tab. We'll paste that over here, and we're going to make a few changes over here. First, we're not going to be providing the ID as part of the body because that's coming as part of the URL. I'll remove that. And then for the name, it's not going to be Street Fighter 2. Let's say this is going to be Street Fighter 2 Turbo. And then let's say that the price, well, it is on sale, so it's going to be just $9.99. And then release date is going to stay the same, but we're going to be removing the time portion of it. And then the rest stays just the same. Okay, so let's go ahead and click on send. And as we can see, we are getting the expected 204 no content result right there. So which means that this was a success. And if we go back into our get by ID endpoint and we request this element once again, click send, you can see that now we're getting Street Fighter 2 Turbo right there. And the price has also changed. So the update was successful. And then just to make sure that the implementation is correct, let's go back into put and let's try to update an element that does not exist. So again, let's say number 4 does not exist. I'm going to go ahead and click on send. And then as expected, we are getting a 404 not found because the element does not exist in the API. So now that we have our endpoint for updating games, let's go ahead and implement our final endpoint, which is the one that is going to allow us to delete games from the API. Let's now go ahead and implement our last endpoint for this API, which is going to be the delete endpoint. Right, so here we're back in our program.cs file, and let's just scroll down all the way to the end. And we're going to be defining our brand new map delete method. So app.mapDelete, and the route that you want to receive here is once again games, and then the ID of the element to delete, so ID just like that. And then as the parameter, you want to receive here again that ID as an integer in ID, and then we'll define again our arrow function to define what is going to be the logic for that deletion. So once again, the logic here is going to be very similar to the previous, some of the previous ones. So what I'm going to do is just copy the logic that we have for the put operation. So I'll copy the put operation right there. I'll paste that down into our delete method. And all we're going to do is just remove this section over here. Okay, and then I'm going to remove this. And then what we're going to do is just say that if existing game is not null, right? So in this case, we were able to find the game. So in that case, we're going to say just games.remove, and that's going to be existing game. All right, and let me actually rename that variable. Existing game should not be needed here. So I'll do F2, and let's just rename this into game. Okay, so the idea is that we go ahead, we try to find the game, right? And if we are able to find it, we remove it from our list of games, right? So it's remove it from the REST API. If we are not able to find it, it really doesn't matter because this is a delete operation. What we want to do is always return the same result or have the same behavior, regardless of if we are able to find the game or not, right? So it doesn't really matter if we find the game or not, we always return just no content, which means that it was a success, right? And in all cases, the game should just not exist after the invocation into this delete endpoint. So let's go ahead and test this endpoint. So I'll do Ctrl J, let's do .NET Run, and let's go back into Postman. And first I'm going to copy one of the games that we could go ahead and, well, let me just copy the route. So we know the route, so I'll copy that. And then I'm going to open up a brand new tab, which is going to be for the delete verb over here. And I'll paste the route over there. And let's choose just one game for deletion. Let's say we're going to be deleting game 2. Okay, let's see what is game 2. So let's go back into the first tab and let's get the list of games once again. Game 2 is Final Fantasy XIV, right? So this game 2 should be deleted after we made the invocation. So let's go back into delete, and we're going to be deleting game 2. And yeah, that should be all it is. We don't need a body in this case. All we have to do now is just click on send. Okay, and we are getting the expected result. As you can see here, we are getting a 204 no content. So that means that it should have been a success. So if we go back again into our list of games and hit send, we can see that there is no more a Final Fantasy XIV game with a D2. There's nothing there, right? So the game has been removed. So that was a success. And just to verify that things are working properly, we're also going to try to delete a game that does not exist, right? So let's say number 4. And like I said before, regardless of what game we specify here, the result should always be the same, right? So I'll click on send. And as you can see, we once again got the 204 no content, right? And so that game 4 does not exist, and it never existed really. So that is the end of this model, and now we have a complete REST API, right? It has all of the expected or traditional endpoints, and it is fully functioning, at least with our in-memory list for now. So with this in place, let's finish this model over here, and let's move into the next model, where we're going to be looking at a few techniques to improve the way that you organize your REST API code, and we're also going to be looking at validations of the inputs that you're going to be receiving in your REST API. In this model, you will learn a few techniques to improve the way you organize your REST API code and also to properly validate data received by the API. By the end of this model, you will have a solid understanding of the following: how to use route groups to organize your API endpoints, how to validate the API parameters, and how to use extension methods to better code organization. Let's see how we can start organizing our code a little bit better. And so here we're back in our program.cs class, and one thing that you may have noticed is that we have been using the very same root path for our endpoints over and over again, right? So we have, for map get, we have /games, also for the other get we have /games, and then for post, we also have /games, same thing for put, same thing for delete, and for all of the endpoints, right? And so luckily there is a feature that we can use here, so we don't have to specify this thing over and over again, and that is called route groups. So with route groups, you can pretty much group a series of endpoints that share something common, right? So that you can apply things to that group together, as opposed to endpoint by endpoint. So let's see how to use that. So what I'm going to do is just go just under our app declaration. I'm going to do this following. So I'm going to say var group equals app.mapGroup. Okay, and in this declaration of the map group, you can go ahead and declare the prefix of your endpoints, right? So in this case, as we know, the prefix is /games, so I'm just going to copy /games over there, right? And that defines our route group. And now that we have defined the group, we can go ahead and just use it for each of the endpoints, right? So now we can say, instead of app.mapGet, we can say group.mapGet. And then instead of specifying /games for the pattern for the endpoint, what you can do is just either leave it empty because it's not needed, right? Because it comes from the group directly. Or what is more common, you would just put / like that, and that will be good enough for that endpoint, right? And the same way that you can do that, you can do the same thing for every other endpoint, right? So let's do it for the other map get. And in this case, we will only specify /id. That's all that is needed. Right? And then coming down into our map post over here, again, we'll say group, and then we'll just say /, and then for put, again, we'll do group, and then just /id. And lastly, for our delete method over here, we'll say again group, and then /id. And so you're going to see how this feature is actually going to become very handy moving on, because we will be doing a bunch of things at the group level as opposed to the endpoint level. It's a nice way to group multiple endpoints together. Now let's verify very quickly that things are working just as expected. So I'm going to go ahead and open my terminal. I'll just do .NET run here. And then let's go back into Postman and let's try just a couple of requests to verify that things are working. So here I am in the Get All Endpoint tab here. So I'll just click on Send. Let's see what we get. And so yeah, as expected, we are getting our 3 games just fine. No issues with this. And then let's go into our Post endpoint over here, where we're going to be creating this brand new game, right? So I'll go ahead and click Send. And as you can see, the game was created successfully without any issues. So as you can see, there is no change in behavior really, but now our code is organized in a much nicer way. And like I said, we're going to be using this map group for a few other things down the road. So now we have this in place. In the next lesson, we'll see how to add server-side validation to our API. One of the things that you should always consider when building a REST API is how you're going to perform the validation of the input parameters. And why is that important? Well, for instance, here I am in the in Postman in the post request, right, that we created a few lessons ago. And let's see what happens if I, for any reason, provide an empty name, right? So instead of providing the actual name, it's just an empty string over here. So let's see what happens when I go ahead and click on send. So notice down here, I am indeed getting a created result, which is already strange, right? So the item should not have been created because it didn't have a valid name. And also I am getting, well, that empty name right there. So this kind of thing should not happen. And furthermore, I can do also other strange things, like for instance, the price. I mean, the price should not be that, like perhaps more than $100 for a game, but I could go ahead and totally introduce a price of something like that, right? I could do that and I could hit send, and now we have that huge price for our game, which is not making much sense. So we have to do something to validate those inputs before they can make their way into a REST API. So let's see what we can do about that. So let me go back into our API over here. I'm not going to stop my server, close my terminal. And the first thing that we're going to do is just go back to Explorer and go into our game entity over here. So what we're going to do is use this feature called data annotations to annotate each of the properties that should have some sort of validation. And let's start with the name, because we said that the name should not allow an empty string, right? It should be required. So for that, we're going to just add one attribute here, which is named required. Okay, and this attribute requires another namespace, so I'm going to do control dot so that we can use system.componentModel.data annotations. So let's select that one right there, and starting now, it is not possible to introduce an empty string for the name. That's going to be automatically validated and rejected if that comes in. And not only that, we can also make it so that the length of the string is also limited, right? So we can say string length, and let's say that we put a value of 50 here. So this means that from here on, the strings for the name cannot be longer than 50 characters, right? So that's a way to control also the length. And just like we can do that, let's go ahead and do the same thing for the other, a few of the other attributes. So I'm just going to copy that. And for the genre, I'm going to go ahead and say that it is also required. But in this case, perhaps 20 characters is good enough. We should not have genres bigger than that for genre. Now let's move on to the price. Now the case of the price is going to be that what we really want is to make sure that the prices are not either negative, and also we should not get a price more than $100, because that's really, I would say, the limit for the price of a video game. And usually they don't cost more than 70 bucks perhaps. But let's say in this case, we're going to add the range data annotation. And so we're going to say that it goes from 1 and to 100. Okay, so with that, any price that comes in, it has to be in that range. Any other value is not going to be allowed. And lastly, let me scroll down a bit more. We're going to do something about the perhaps the release date. We'll just keep it there. But for image URI, we're going to say that to start with, it should be a valid URL, right? So to make sure that it is a valid URL, we're going to be using the URL data annotation. So it has to be a well-formed URL. And also, we're going to be also using the string length attribute to make sure that these URLs should not be perhaps more than 100 characters. That should be good enough. And with that, we have introduced all of these basic data annotations that are going to make sure that we have valid values for all of our properties. Now, in order to use these data annotations, we have to do a little bit more, because just adding the annotations is not going to enforce them in our endpoints. So in the next lesson, we'll see how to use what is known as a NuGet package to import existing functionality to enforce our data annotations. In this lesson, you will learn about NuGet and the multiple benefits of using NuGet packages in your software development workflow. So what is NuGet? Well, in simple terms, NuGet is the Microsoft-supported mechanism for sharing code in .NET. It is an essential tool that allows developers to create, share, and consume useful code. Let's see why this is useful with a quick example. Here we have John, who has been working in his brand new Web API project. The project currently produces one assembly, myAPI.dll, which contains all the code for John's API. However, this API is missing some essential validation logic, which John could certainly go ahead and implement from scratch. But fortunately, Jane, who does some open source work on her spare time, has already written all the validation logic that John is missing and produced an assembly out of it, coolvalidations.dll. Jane thought this assembly could be useful to others, so she created a NuGet package which contains the assembly and then published it to NuGet.org, the public cloud service where anyone can share packages with other developers. John got news about this package and decided to install it in his Web API project. And thanks to this, he was able to quickly add all the missing validation functionality as opposed to having to write it from scratch. So using NuGet packages brings in several benefits to .NET developers. They allow developers to encapsulate reusable code and libraries into easily consumable packages. They simplify the process of managing dependencies in a project, since NuGet automatically resolves and installs any required dependencies. Developers can avoid the need to write and maintain certain functionalities from scratch. Instead, they can leverage existing packages that have already been tested and optimized by the package authors and the community. NuGet has a vast ecosystem of packages available, covering a wider range of programming languages, frameworks, and tools. Finally, NuGet allows package authors to release multiple versions of their packages, which enables developers to choose the appropriate version based on their project requirements. In the next lesson, you will install your first NuGet package to enable the missing input validation in your REST API. Like I mentioned before, in order to enforce the data annotations that we added a couple of lessons ago, we have to do a little bit more, because just adding the annotations is not going to enforce the validations in our endpoints. To do that, we have to introduce this feature called endpoint filters, which is something that we could definitely write manually, an endpoint filter for this case. But fortunately, somebody else already wrote the logic to enforce the endpoint filters that we need here. And that person created a NuGet package to share that logic. And if you ever want to look for a NuGet package, what you can do is just go into this page over here, which is nuget.org. right here. And this is probably the biggest library of free NuGet packages available. And there are hundreds and hundreds of NuGet packages for all sorts of purposes. Now, the one NuGet package that we want to use in our project right now is this one here called minimal apis.extensions. Right, and just looking for that, the one that we're looking for right now is this very first one, minimal apis.extensions by David Edwards. So I'm going to click on that one. And that's going to take us to the page that describes pretty much what this package is for and how exactly you're going to install it and use it in your project, right? And not only that, you can also see all of the versions of this package available, because there can be multiple versions, each version bringing in either bug fixes or perhaps new features, right? So at the time that I'm recording this, the last version is version 0.10.1, right? And so in order to use the NuGet package, you can see we have the command line that we can use to import and use the NuGet package. So I'm just going to go ahead and copy that. So I'll copy that, I'll go back into my project over here. And now what we can do is just do Ctrl-J to open our terminal here. And I'm just going to paste what I just copied from there, right? So we're going to be installing this package. I'll hit enter. And with that, the NuGet package has been imported into our project. And just to confirm that, what we can do is just go back into our Explorer, into gamestore.api.csproc, the project file. And you're going to see that now we have that brand new NuGet package reference set in here. So from here on, we can use any of the classes or types, introduce it in that NuGet package. And because of that, what we can do is the following. So let's go into program.cs over here. And since we are using the endpoint groups feature, what we can do is just enforce these validations for all of our endpoints in one shot. So we're going to go into this line here where we define the group. And we're just going to add a dot at the second line here. We'll say dot with parameter validation, right? Which is a function that is offered by that NuGet package that we just introduced, right? So just by doing this, there's going to be an endpoint filter that checks for all the data annotations in our entities. So anytime somebody tries to post a request into our endpoints with invalid data, those are going to be rejected. So let's see how that works. I'm going to do Ctrl-J, and I'm going to just run our project right there. And let's go back into Postman, okay, over here. And we're going to be trying out the same invalid request that we tried before, right? Which has the empty string, and it has the invalid price, right? So I'm just going to go ahead and click on send. And this time, as you can see, we are getting a couple of validations, right? So first we have a nice title here that says that one or more validation errors occurred. So that's great. Then we also got a status code 400, which is the correct status code when we have validation errors, right? And not only that, we have one specific validation error for each of the errors that are happening in our API right now, right? So we have that for the name, we have that the name field is required right there. And for the price, we have that the price must be between 1 and 100. And so this is a well-formed error that was all created automatically just because we're using data annotations and the minimal apis.extensions NuGet package. So that's fantastic. So now we can go ahead and actually fix this. So let's go back and put a proper name here, Minecraft. And then for the price, well, let's put again something reasonable, like $19.99 for instance. And then if you just click send, now this time it's going to succeed. As you can see, now it is all good and there are no more any validation errors. So yeah, so that's a very simple way to add server-side validation to your project. And in the next lesson, we're going to see how to use another feature called extension methods to further organize our code much better. One thing that might be bothering you at this point is how much code we have so far in our program.cs file. So if you remember, we have the code for defining our list of games, our in-memory list of games. As you can see there, we have our builder object, our app object, our map group, and then we have the definition of all of our endpoints, right? So the get endpoints, and then we have the post endpoint, put endpoint, delete endpoint, all of this code, right? And so I think this is just too much code for a file that is meant to be just the entry point of the application. So because of that, we are going to be refactoring all of the code here that has to do specifically with the endpoints into a brand new class that is going to be in charge of defining these endpoints. And we're going to be using what we know as extension methods to make this very easy. So first thing we're going to do is just to create a brand new directory under gamestore.api. So right click, new folder, and let's call this folder just endpoints. And inside endpoints, we're going to be defining a brand new class. So new C# class, and let's name it games endpoints. And so just like we have been doing so far, let's go ahead and clean up this file by converting to file scope namespace, just like that. And let's clean up these additional namespaces from the top. Now, since this class is meant for extension methods and all extension methods should always be static, we're going to make this class also static. There's not going to be instance methods over here. And now let's go ahead and define our extension method by stating public static. Like I said, all extension methods are static. And then the return type is going to be route group builder. The name of the method is going to be map games endpoints. And then the parameter here is going to be the type that we're going to extend, right? The type where we're going to add an additional method without having to modify the type itself. So the type is going to be endpoint route builder. And then the name of the parameter is just going to be routes. Now, since we do want to extend endpoint route builder, what you want to do is to specify this keyword here. So that enables us to actually extend the method by adding our brand new method. Now, why is it we want to extend endpoint route builder? Well, if you go back into our program.cs class over here, program.cs, and if we scroll down, notice that if we go into the definition of, let's say, map-get, right? So map-get, I'm going to right-click and go to definition. You're going to notice that this method here is actually an extension method on top of endpoint route builder. Right here, you see it is extending endpoint route builder. And if we go back again into program.cs and we also look at map group, for instance, I'm going to do F12 to also do the definition. This one also extends endpoint route builder, right? So pretty much what we're going to do is to do yet one more extension method on top of that type to refactor all of the stuff that we're going to do over here, right? So it is the right type for us to extend, right? So endpoint route builder. And so what we're going to do now is just to bring in all of this code, right? Starting with in our program.cs file with the declaration of group all the way to the end until the definition of our delete method, right? Map delete. I'm just going to go ahead and copy that, and I'll paste that over here, there. Okay, so this is so far our extension method. And now at this point, the object that we are using to invoke all of the map methods is no longer named app, but is named routes, right? So I'm going to just copy routes, put that over here, right? So routes.map group. And then let's also bring in the right type for game, right? So I'm going to select game here, do control dot, and then I'm going to select gamestore.api.entities, right? So we have that definition, okay? And then we're also missing, of course, the list of games and the definition of our get game endpoint name. So let's go back to program.cs, let's go all the way to the top, and then let's select both the const over here and the full list of games. Let's select all of that over here. Yep. So let's go ahead and copy that into get games endpoints. So let's define this just outside of method, just under the class definition. I'll paste that over there, over here. So let's line up this a little bit better. And of course, since we're going to be using this games variable inside of a static class, we want to define this variable as a static itself. So it's going to be static list of games, right? Okay, so we have our const there, we have the list of games, and then we have map games endpoints, right? So most of the code is looking good now. And the only thing missing here, I think, is just the return type, right? So we said that we're going to be returning route group builder. And that is because that is a type that our group object is made of, right? So our group object, as you can see, it is a route group builder. So what we want to do is just to return group in case we want to making continuous calls into group from our program.cs class, right? So we're just going to go ahead and return group. And so, yeah, that's pretty much the definition of our map games endpoints extension method, right? And so that's what we have in our class right now. And what we can do now is just go back into program.cs and we can start getting rid of stuff. So now we can delete this const and the list of games. So we're going to delete that. Okay, those are deleted. And then we can go ahead and remove most of the code here. So I'm going to remove all of the map extension calls over here. Okay, except for the group. And then what we're going to do, instead of defining the group here, is just say, removing this, app.map games endpoints. And of course, we will have to import another namespace here. So I'm going to do control dot, and then we'll have to select using gamestore.api.endpoints, like that, right? And then we can go ahead and clean up this because we don't need the entities namespace anymore. So now our program.cs class or file, as you can see, is just made of 8 lines that make much more sense. All we do is just declare the builder, declare the app, define the endpoints, and we're done, right? And all the logic for the definition of the endpoints is actually now refactored into this class which only purpose is to define and manage all of these endpoints, as you can see. And so, yeah, just let's make sure that these things are still working just fine. So I'm going to do .NET run here to verify that things are working properly. And now let's go back into Postman and let's test a couple of those endpoints, right? So let's go, this is going to be our get all games endpoint. So let's go ahead and hit send. And as you can see, we are still getting our list of games just fine. We go to post, we can go ahead and we have a body here, of course. Yeah, we have a body. Hit send, and it is working as expected. All good. So yeah, extension methods are a very handy feature to, as you can see, organize code better. And yeah, that's going to be the end of this model. And in the next lesson or in the next model, we're going to introduce a few design patterns that will help us future-proof our API for any future changes. In this model, you will improve your REST API with a few popular design patterns and best practices to ensure your code is ready to adapt to future changing requirements. By the end of this model, you will have a solid understanding of the following: how to use the repository pattern for better data manipulation, how to use the dependency injection pattern to write more maintainable code, which are the different service lifetimes available in ASP.NET Core, and how to use data transfer objects to define clear contracts between client and server. In this lesson, you will learn about the repository pattern and why you should use it in your applications. To understand why you may want to use a repository, let's say that today we have the application logic of our service talking directly to our SQL Server database. However, a few months or years from now, our application has become incredibly popular and the constraints of a relational database are not allowing it to scale. So it's time to move to a NoSQL database, like Cosmos DB perhaps. Sadly, given the way things have been set up, we would likely need to rewrite a good chunk of our application logic in order to talk to the new database, which is not just going to take a while, but also is very error prone since bugs in the application logic can easily surface as it gets adapted to the new data access code. Instead of this, we can take advantage of the repository pattern. But what is a repository? A repository is an abstraction that encapsulates the logic for accessing and manipulating data. Its main purpose is to abstract away the details of the underlying data access technology from the rest of the application. Going back to our example, we will now introduce a repository between our application logic and the database. This repository is the only one that knows how to talk initially to our SQL Server database, and is the only one that our application logic will interface with. Then, if we ever get the requirement to move to another database, the only thing that we would need to change is our repository, but the application logic stays the same. So, the repository pattern is important because it decouples the application logic from the data layer and minimizes duplicate data access logic across our service. Let's now see how to apply the repository pattern into our REST API. Before we introduce the repository pattern into our codebase, I'll just have to mention that there is an associated pattern called unit of work that we will not be using here because it's mostly related to having to perform transactions across multiple entities or multiple tables in your data storage. But we will not be using transactions across this course, so we don't really need to go into the unit of work pattern. So we're going to be implementing a simple version of the repository pattern here that should be good enough for what we need to do. So the first thing that we're going to do here is to introduce a brand new directory just under gamestore.api. We're going to right click and say new folder, and this is going to be named repositories. And inside repositories, we're going to be, well, let's right click, let's do new C# class. And the name of this class is going to be, since this is going to be kind of an in-memory repository of games, let's name it in-mem games repository. So let's do a little bit of cleanup here. Let's step over here in the name of the namespace, control dot, convert to file scope namespace, and then also on the usings to remove unnecessary usings. So what should we bring into this class? So let's go back into our endpoints class, games endpoints. And so here's where we have declared so far our list of games. So we're going to, first thing to do is just to bring in that list of games into our repository class. So I'm going to select the entire definition of our games, just like that. Okay, and let's go ahead and cut it. We're going to go ahead and cut this, and let's put it into our in-main games repository right there. And then let's go ahead and select the game word over here, control dot, so that we can use gamestore.api.entities namespace, just like that. And then this should also be likely read-only because it's not going to be modified anywhere else in the class. So I'll do control dot, and I'll add a read-only modifier. And then we can start defining the repository methods, right? So let me collapse this for a moment, and let's start scrolling down here just under the definition of our games. There. So the first method we're going to be defining is the one to retrieve all of the games. So this is going to be public, and then the return type is going to be one of the most generic types that you can return here, just so that the client can easily manage the list that we're going to be returning. So that type is going to be IEnumerable, right, which basically represents a list of objects, right, that can be read in a sequential manner. The name of the method is going to be getAll. All right, and then what should we do in this method? Well, at this point, all we have to do is just return games. Okay, so that's going to return the entire list of games to whoever invokes this method. The next method here is going to be the method to return just one game by ID. So in this case, we're going to implement public game get, and then the parameter is going to be that ID, just like that. And so what logic should we have here? So if we look at games endpoints, so let's go back to games endpoints, and what we can do is just copy the logic that we have in our map get endpoint over here. Just copy not all the logic, but just the logic to retrieve the game. You see, we use a find method to get the appropriate game. So I'm going to copy that into in-mem games endpoint, and we're going to say return games.find, and then whichever game is found via the ID parameter, right? Via the lambda expression over there. Now this method might return a null, right? So it's a nullable return. So because of that, we're going to qualify the game return type with the question mark, making it so that this is also a method that can return a nullable object. So if we cannot find the game for any reason, we're going to be returning a null value. Okay, so let's scroll down a little bit more. And now we're going to be defining the method to create a game in the repository. So let's define this as public void create game. Okay, so we receive the game as a parameter, and then what we want to do is a couple of things. So, and let's actually go back into games endpoint to see what we were doing in the post endpoint over here. So yeah, it's pretty much the same idea. So we have to calculate the max number of the ID that we have so far, incrementing one, and then we just add the game to our list of games. So let me just copy this logic over here. I'm going to copy that into our repository. Okay, so game.id, it just gets the ID plus one, and then we add it to the list of games. So moving on, let's go into our update method. So public void update, and here we're going to be receiving our updated game, right? Updated game. Now this is the game with already with all of the properties updated, right? Which is going to be done by the game's endpoints. And so all we have to do now is just to set this updated game into our list of games. So what we want to do now is to somehow find the index of this of the game to update in our list of games, and then let's just go ahead and update that game in that index. So let's do this. Bar index equals games that find index, and for which game? Well, we're game.id equals updated game.id. Right, so that's going to give us the index of the game in our list of games, and then we can just go ahead and say games subindex equals updated game. Right, so that's all we have to do for our in-memory repository for the update method. And lastly, let's go ahead and do the implementation for our delete method. So it's going to be public void delete, and then all we have to receive here is the ID of the game, int ID. And then the logic to find it is going to be very similar. So let's go ahead and copy the line from update, just like that. Except that we don't have updated game here, or we only have the ID. So let's just say ID. Okay, and after that, what we can do is just say games.remove at, and then the found index. And one last thing to do, if we go back all the way to the declaration of our class over here, is to make a small change to our games list over here, because this list does not need to be static anymore. Right now it's going to be part of our in-main game repository, so it should follow the life cycle of this class itself as opposed to be a static object. So we're going to be removing the static declaration here, and in fact let's just add private here, so clearly declare that this is going to be a private variable in our class. All right, so no more static for games. And with that, let's go back into our games endpoints.cs file and see how we can start using our repository over there. So let's go back over here. So let's go all the way up now here, and let's remove a bit of these spaces. We don't need those. And what we're going to do is just at the start of our map games endpoints class, method, we're going to be defining our repository instance, right? So we're going to be defining in-mem games repository, okay, and then likely we want to do control dot here to introduce gamestore.api.repositories, okay, and then equals new. Okay, keep in mind that our code base is constantly changing, right? So I'm going to be instantiating the repository just like this for now. Later on, we're going to learn another technique to bring in the repository in a much more flexible and testable way. And so now that we have a repository in place there, we can start taking advantage of it, right? So now for the map get all, the first endpoint here, what we can do now is just say repository.getAll. And then keep scrolling down. If we go into our map get by ID over here, what we can do is the following. What we have to do is just say repository.get, and then we pass in the ID. And since we are here, one small update that we can do also here is to just refactor this bunch of lines. I think we can do this actually in just one line. So what we can do is just say return game is not null, right? So if it is not null, we say results.okay with the game, right? And otherwise we say results.not found, right? Just a small simplification, and with that we don't have to add all of these extra lines. Now let's go with our post method over here. And what we can do now, instead of these two lines, we can just say repository.create, and we have now our game right there. And after that, we just return as usual. And then let's move on into our put method down here. And here we can use a repository in a couple of places. So first, to find the game, we can now say repository.get with the ID, and then all the way to the end, just before returning, we have to actually update the game inside the repository. So we have to say now repository.update existing game, right? So that's going to update the game in our list of games. So let's move on into our last method, our delete method over here, where once again, we're going to be finding our game using repository.get with ID. And then to remove it, we are going to say, instead of this, we're going to say repository.delete with that ID. So as you can see, we have now introduced the repository into our map games endpoints API here, extension method. And the main benefit is that now we don't have that list of games living in our endpoints anymore. The list of games, the memory list of games is actually living now directly in our in-mem games repository, right? So we have decoupled the management of the data from our endpoints themselves, right? That's going to be super useful moving on. And so, well, let's just go ahead and verify that things are working properly. Once again, .NET Run. We'll do a very quick test here. Just make sure that, let's go back to Postman and let's go ahead and do a send to get all the games. Yeah, that's working properly, right? And then for a post, let's go ahead and send, and that's also working properly. So yeah, things are working just fine. And in the next lesson, we'll learn about another very, very important design pattern known as dependency injection. In this lesson, you will learn about the dependency injection design pattern and the multiple benefits it brings in to your applications. To understand what dependency injection is, let's start by looking at two classes, myService and myLogger. myService uses the logThis method of myLogger to log messages to a file anytime myService performs an important operation. Since myService uses some of the functionalities of myLogger, like the logThis method, we say that myLogger is a dependency of myService. Now, in order for myService to start using myLogger, it creates an instance of myLogger in its constructor. And after that, it can start calling the logThis method. At first glance, it doesn't look like this presents any problems. But consider what happens when the authors of myLogger decide to slightly modify it so that a new myFileWriter object needs to be passed on its constructor, because that's where the output file is now defined. The required changes look simple to implement, but they reveal a few important problems. myService is tightly coupled to myLogger in such a way that anytime myLogger changes, there's a need to also change myService, as it happened here when the constructor started requiring a myFileWriter instance. myService needs to know how to construct and configure the myLogger dependency, like is the case here with the myFileWriter object, which needs to be configured with an appropriate file to send the output logs. This makes it hard to test myService since unit tests won't be able to mock or stop myLogger. An output.log file will always be created, which would slow down tests, and this assuming that the tests have access to a place to write files to. Fortunately, there's a better way to do this using what is known as dependency injection. Let's go back to myService and its myLogger dependency. myService still uses the logThis method, but this time myLogger is not explicitly constructed by myService. Instead, myLogger is passed in as a constructor parameter. myLogger is injected into the myService constructor. This way, myService doesn't need to know how to construct or configure the logger, it just receives it and can start using it right away. But if myService doesn't construct the logger, who does it? Well, ASP.NET Core provides the iService provider, which is what is known as a service container. Your application can register myLogger and any other dependencies with iService provider during startup, which is typically done in your program.cs file. Then later, when a new HTTP request arrives and your web app needs an instance of myService, the service container will notice its dependencies and it will go ahead and resolve, construct, and inject those dependencies into a new instance of myService via its constructor. This enables multiple benefits for your application. To start with, myService won't be affected by changes to its dependencies. It doesn't matter how many times the constructor of myLogger changes, there is no need to change myService. Moreover, myService won't be created instances of myLogger, so it doesn't need to know how to construct or configure it. If your application uses minimal APIs, dependencies can also be injected as parameters to your minimal API endpoints. Finally, dependency injection opens the door to using dependency inversion. But what is dependency inversion? The dependency inversion principle states that code should depend on abstractions as opposed to concrete implementations. Let's bring again our myService class and its myLogger dependency. Currently, myService depends directly on myLogger, which allows it to write logs to an output file. But let's say that now we're moving to the cloud and we need to start sending logs to some sort of cloud service. For this, we would like myService to start using a new Cloud Logger class. We could modify myService to receive and use a Cloud Logger instance instead of a myLogger instance. However, what we can do instead is modify myService so that it depends on a new iLogger interface, which provides all the required logging functionality. Then we can have both myLogger and Cloud Logger implement this new interface. With this, we are decoupling my service from the logger dependency, allowing it to use my logger, cloud logger, and any future logger implementations without ever having to modify my service. The only thing that the different loggers need to do is to implement the interface that my service depends on. In terms of the code, this is how you would now inject the logger into my service. So the main benefit of using the dependency inversion principle is that dependencies can be swapped out without having to modify the class that uses them. But also, it is now much easier to test my service since the logger dependency can be easily mocked or stopped. And finally, your code is now cleaner, easier to modify, and easier to reuse. Now, before we start using dependency injection in our code, there is one more important concept to understand, which is the service lifetime. In this lesson, you will learn about the different service lifetimes available in ASP.NET Core. We now know the basics of dependency injection in ASP.NET Core. We know that on startup, your application will register the dependencies like my logger here, and later, when an HTTP request arrives, iService provider will resolve, construct, and inject an instance of my logger into a new instance of your class, my service in this example. What is not clear is what happens when a new request arrives. Should iService provider create a brand new my logger instance for the new request? Or should it reuse the same instance? What if another service that also has a dependency on my logger needs to be created in response to a new request? Same my logger instance or new my logger instance? The answer to this lies in the service lifetime, which you configure when you register my logger with iService provider. There are 3 available service lifetimes, so let's take a look at each of them. Let's say that my logger is a very lightweight and stateless service, so it's okay to create a new instance every single time any class needs it. In that case, you will register my logger with the addTransient method. When the first HTTP request arrives, the iService provider, as usual, will resolve, construct, and inject a new instance of my logger into my service. However, when a new HTTP request arrives, iService provider will construct and inject a brand new instance of my logger, which has nothing to do with the first instance. Furthermore, if there's any other service that participates in any of these HTTP requests and also has a dependency on my logger, it will also receive a brand new instance of it. So, transient lifetime services are created each time they are requested from iService provider. What if my logger is a class that keeps track of some sort of state that needs to be shared across multiple classes that participate in an HTTP request? In that case, you will register my logger with the addCode method. Here, when an HTTP request arrives, the iService provider will again resolve, construct, and inject a new instance of my logger into my service. But if there's any other service that participates in the same HTTP request and that also has a dependency on my logger, it will receive the exact same instance of this dependency. However, if a new HTTP request arrives, the service container will create and inject a brand new instance of my logger instead, totally related to the previous instance. So, scoped lifetime services are created once per HTTP request and reused within that request. Finally, let's say that my logger is not cheap to instantiate and it keeps track of a state that should be shared with all classes that request it during the entire lifetime of your application. Then you will register my logger with the addSingleton method. As usual, when an HTTP request arrives, the iService provider will resolve, construct, and inject a new instance of my logger into my service. And if there is any other service that participates in that same HTTP request and that also has a dependency on my logger, it will receive the exact same instance of this dependency. But furthermore, if a new HTTP request arrives, the service container will once again provide the same instance of my logger to any of the classes that request it. And it will keep doing so until the application is shut down. So, singleton lifetime services are created the first time they are requested and reused across the application lifetime. Now that you understand dependency injection in ASP.NET Core and the different service lifetimes, let's get back to the code and see how we can use these concepts to register the repository instance needed to interact with the data. Let's see how we can use the dependency injection design pattern in our .NET REST API. So if you remember, if you go back into endpoints, games endpoints.cs, you remember that we are creating currently the instance of our repository right here at the start of the map games endpoints method, right? So what we want to do now is to switch this so that instead of this, we're going to be injecting one instance of repository into each of the endpoints that actually need it. That way, we're going to be avoiding the coupling that we have today between our games endpoints class and the concrete in-mem games repository instance. So the first thing to do is to go back into repositories and in-mem games repository. And what we want to do here is to first extract the interface of this class so that later on we can inject that interface into the games endpoints class, right? So that way that class doesn't need to know really exactly which concrete instance is being created. And so to extract the interface, what you can do, I mean, you can create it manually, but there's also a good way to do this automatically. If you just click on the in-main games repository type over here, you can use this label over here and just select the option that says extract interface, the very first one there. Go there, and that's going to go ahead and generate the interface for you. Okay, and not only that, now our class is actually implementing that interface, as you can see. And now that we have the interface, we would also rename that interface because that name is not making much sense, right? It should be a little bit more generic. So I'm going to just tap F2 in my keyboard here so that we can do a proper refactoring of this interface. So let's just rename this one into iGames repository, right? So it's more generic. Hit enter and notice that now we have the brand new name over here, and also we have that brand new name as the one that is implemented by in-mem games repository. And with that in place, the next thing that we want to do is to move this interface out into its own file just for better code organization. So I'm going to click on the label over here, and then you can select the extract interface, the move type to iGames repository option over here, there. And by doing that, as you can see, the file has been moved over, created over there in iGames repository, right? And it's out of our in-main games repository class. We go back into iGames repository, you're going to see it's just the same interface, but it has been moved into a new file. And with that in place, we are ready to start taking advantage of this new interface in our games endpoints file. So let's go back into games endpoints, and I'm going to collapse this so that we can see a bit better. And the first thing to do here is to stop declaring, of course, the repository like this. We're not going to have that coupling anymore, so that goes away. And then what you want to do is to, like I said, inject the interface into each of our endpoints. And to do that, all you have to do really is just go into the parameter that's defined for each of our endpoints and declare the type. So you're going to say iGames repository, like that. And just by doing that, whenever a request comes in that matches this endpoint, the service container is going to find out which is the class that implements iGames repository, and we're going to be doing the registration in a second. And it's going to instantiate in-mem games repository, and it's going to provide that instance or inject that instance right here so that the endpoint can start using it like it is doing right now. And we can do the same thing with each of the other endpoints. So let's go ahead and let me just copy this, and then let's enter this as the first parameter in the next endpoint, the get by ID, just like that. And let's do the same thing for the other endpoint. So let's go to map post, we put it over here. And by the way, the order, it doesn't matter, the order of parameters, you can do it in any order. I'll just prefer to do this as the first parameter for now. So let's go for map put. And then finally, let's go for map delete. And so yeah, with that, there's no more coupling between games endpoints and our repository class. Everything is being done via dependency injection. So notice that games endpoints, now it doesn't really know which specific type is being used as a repository. It only knows that there is an interface and it will work with that interface, right? So somebody else has to figure out what is the actual concrete instance. So that's what we have to do now. So now we have to do the actual registration of the concrete instance that's going to map to iGames repository. So let's go back into our Explorer and into program.cs. Let's collapse this. And in order to register your instance of the repository, what you want to do is take advantage of your builder object, right? So what you can do is just say builder.services, and services here is the entire services collection that of the services that have been registered into our builder instance. Right? So this is the collection where you can add your services into. So to add a service, what you have to do is just do dot, and then you're going to find a bunch of methods here to represent the different ways that you can register the service. So you can do, for instance, a transient, right? If you wanted to do a transient service, or you could do add scoped, for a scope service, or you can do add singleton also. Now, the type of registration that we want to do here is add singleton. But before we do that, let's actually take a look at add scoped, and let's see what would happen if we use it add scoped as opposed to add singleton. So let's do add scoped, and what you want to do now is just to switch into exactly to declare the interface first. So in this type parameter, let's do iGames repository. All right, and to use that, we'll have to step into there and do control dot, so that we can use GameStore.api.repositories, this very first one over here. Okay, so we're using that namespace now, and then you specify the concrete type that you want to get activated whenever somebody asks for that interface. So in that case, in our case, it's going to be in mem games repository. So with that, we have registered our service with the service container. And now let's see how this works in action, right? Let's see what happens. So let's do Ctrl J. I'm going to do .NET run. And now let's go back into Postman over here. And we're going to try our first request, which is the one that gets all the games, right? So I'm going to go ahead and click on send. And as expected, this is working fine, right? So we are getting our 3 initial set of games from the in-memory repository. And now let's go ahead and create a brand new game in our post request over here, which is going to be our Minecraft game, right? Just like we did before. I'll click on send, and our Minecraft game has been created. However, let's see what happens if we now retrieve that full list of games, right? So the expectation is that it should have our Minecraft game over there. So let's go back here and let's go ahead and click on send once again. And notice this, there is no more the Minecraft game is just not showing up here. There is no Minecraft game. We only have 1, 2, and 3, the 3 initial games, right? No matter how many times we create the Minecraft game, so I'll click on send, and it was a success, right? It says here that it did got created, but if you go back into get all, click on send, and the game is just not there. So what is happening there? Well, if we go back into our API, the reason why this is happening is because we are using the scoped service lifetime. This means that anytime we receive a new request in any of our endpoints, a brand new instance of in-mem games repository is going to be created, right? So in games endpoints over here, when the initial request comes for map get, then we get one instance of repository over here. And then whenever we do the post call, right, we get another instance of repository, a completely different instance. And furthermore, when we do get, once again, we get another instance of repository over here. And let's see if we can see this more explicitly by using breakpoints. So let's go back to in-main games repository, and I'm going to put a breakpoint over here, right, which is where we are pretty much creating our games list. So this time I'm going to do F5, okay, to start debugging. And so I'll go back to Postman, and I'm going to do the initial send over here. And notice we have our breakpoint over here, right? The games instance is going to be created in main games repository. So we hit play, and so that retrieves the list of games. And now we go back into post, and we're going to go ahead and create a new game, right? So click on send. And notice that we're back in VS Code, and once again the list is going to be recreated because this is a new instance, because this is a new request, because we are using the scoped service lifetime, right? So a new instance gets created, and of course that's not going to have our brand new game. And in fact, if we go back to get all, we click on send, and then once again a brand new instance is getting created. And so that is what's happening here. So that's what this is not working. And so because of this, what we want to do is just go back to VS Code. I'm going to stop this, close that, and then let's go back to program.cs. What we want to do now, just while we're using the in-mem games repository, is to switch from add scope to add singleton. So that's going to make sure that we only get one instance of the repository for the entire lifetime of the application, right? This is likely not what you want to do when you start moving into database access, but for now, so that we can actually play nicely with this API, we want to stick to in-mem and with singleton, but later on we can switch to something else, right? And just for our curiosity's sake, let's see what happens now that we have a singleton, right? So let's do F5 now. All right, let's go back to Postman, and then once again, let's retrieve the full list of games, click send, and as expected, we hit the breakpoint over here where we are declaring the games array or the games list. Click play, let's go back to Postman, and here we have the full list of games, and then let's go back to post, and this time let's go ahead once again and create a brand new game, click send, and notice that no breakpoint got hit, right? So there's no breakpoint. Go back to VS Code, the breakpoint has not been hit, right? It's not there. And then if you go back to get all games, click send. Again, there's no breakpoint because the instance is being reused, right? There's no need to create it again. And now we do have our fourth game right there. So only one instance is created because it is a singleton. And so one more thing to consider here is the following. So if you just stop this for now, is the fact that since in program we are using a singleton now, and since this is just one instance for the entire API, you might run into concurrency issues if you decided to just keep moving forward with the in-mem approach all the way to a production application, right? Because we are using that exact same array in mem games repository. This array is being used for all of the methods that we have here, including the method for creation and the method for update. Right? So if there are multiple requests coming in and for some reason multiple of these methods on the repository are being accessed at the very same time, you may have concurrency issues, right? Between the different elements that are being updated or created in the array. So because of that, this is not going to be the best option. This simple list here is not going to be the best option for you if you wanted to use this in a production application. So you want to switch into something perhaps like a concurrent dictionary or something like that that is actually thread safe. But this one here is not thread safe, but it's going to be good enough for our purposes until we arrive into the new repository that's going to be based on a database. And so that's it for this lesson. And in the next lesson, we will learn about another good practice, which is the use of data transfer objects or DTOs, and we'll see why they are essential for exchanging data between your REST API and your clients. In this lesson, you will learn about data transfer objects and why they are essential for exchanging data between your REST API and your clients. So, what is a data transfer object? Well, a data transfer object, or DTO, is an object that carries data between processes or applications. It encapsulates data in a simple and standardized format that can be easily transmitted across different layers of an application or across different applications. And in the context of a REST API, a DTO can be considered a contract between the client and the server, since it represents a shared agreement between the client and server about how data will be transferred and used. But why exactly do you want to use DTOs in your REST API? To understand this, let's look at a simple request to a REST API, where the client is requesting the data for one of the games. The API receives the request and then asks for the game data from the repository. The repository finds and returns the data in the form of an entity, and the REST API simply forwards that exact entity back to the client in the form of a JSON object. It doesn't seem like there is any problem with this, but consider what could happen if suddenly requirements change and we are asked to rename the price property to retail price. And not only that, we will also start storing a secret code next to each game, which is for internal use only, so it should never leave the backend. However, since we are returning the entities as is, we are now sending both retail price and secret code in our response to the client, which will not just break the client, since it was expecting price and not retail price, but opens the door for the client to read and show a secret that was not meant for it. Because of this, the REST API should never return the entities that came from the repository to clients, but instead it should translate entities into DTOs that conform to the agreement between client and server, which in this case means we always return ID, name, and price to clients, and nothing else. So, the DTO acts as a contract that defines the expectations and requirements for how data will be exchanged between client and server, and you should make sure you always honor this contract on all communications with your clients. Let's now see how to start using DTOs in a REST API. Let's now see how to use data transfer objects, or DTOs, in our .NET REST API. Now, for this, we will be using the record types feature of C# because they allow you to create immutable classes primarily designed to hold data. And this matches our DTO requirements, since the data that comes from them should be immutable, meaning that once the DTO is created, its values should not be changed. So what we're going to do now is go ahead into our GameStore.api directory, the root, and let's just right click and create a new, not C# file, but instead just a standard new file. And this is going to be named dtos.cs. Right, so in this one file, we're going to be declaring all of the DTOs that are needed by our REST API. Now, one thing that we have to remember here is to also add the corresponding namespace. So let's go ahead and add namespace GameStore.api, and let's add here DTOs, all right? So that all of our DTOs are in that namespace. Now to declare these DTOs, let's go ahead and also open our entities class over here, because the DTOs are going to reuse most of the properties of the game entity. So let's go ahead and use that, and let me go ahead and collapse this, and let's see if I can put the game on the right side. So I'll do split right so we can see better. And now we can see the entity on the right side and the DTOs on the left side. Perhaps I'll scroll a little bit to the right. Okay, so the first DTO that we're going to declare is the one that's going to be used for retrieving data from the API, right, for the get endpoints. So we will declare public record game DTO. And I'm going to open and close and just send it to the next line so that we can see better all of the parameters. Now for a record type, all you have to do to declare the properties is just declare them inline inside of these parentheses, right? So in this case, let's go ahead and start with our ID. So let's declare int ID, then we go with the name. Okay, then we go with the genre, and let's keep scrolling down. Then we have our decimal price and date, time, release date, and finally we have our string image URI. Okay, so that is our game DTO, and notice how it is much easier to declare than it is to declare an entire class. So that we will use to retrieve data, and then we have to declare a couple of more DTOs for creation and update of our resources. So let's scroll down a little bit, and let's go ahead and declare our next record type. So it's going to be public record create game DTO. Okay, so same idea. And to create a game, we don't need an ID, as we know so far. So we will start with our name. So string name. And in fact, I'm going to actually copy most of the properties from game DTO here to save time. So very similar properties. But here we have to remember that we also want to account for the validation of all of those properties, right? So we want to bring in all of the data, these data annotations that we were using in the entity. We want to transfer them now into the DTO. So our create game DTO for the name, we want to say that yes, so it is required, right? And also let's do control dot here so that we can use and import system.component model.data annotations. And then this is also string length, and we said it is going to be 50 for the name. Next one, genre, same idea, but the string length is going to be 20, right? And so scroll down. And then we have for our price, we know that we want to use the range data annotation. So let's put that over here for the price. And then we have release date. We don't have anything specific. And for the image URI, we want to specify that it has to be a URL. And it also has to have the string length for 100. So I'm just going to copy that over here. Next, we're going to be defining the DTO, the last DTO, and it's going to be for updating resources, right? And as you're going to see, this is pretty much going to be the same thing as the create game DTO, but you always want to keep it separate because eventually it is fairly likely that the contract for creation and update is going to change, right? So right now our requirements are very simple, so we're not going to notice any difference, but eventually things could change. So that's why I'm going to keep them separate. So instead of create game DTO, this is going to be update game DTO. So what we want to do now is to define also an extension method so that we can easily map from a game entity into a DTO. And we're going to see how that's going to be very useful when we start using the DTOs in the endpoints. And so to do that, let's go back to Explorer. And under the entities directory, let's just right click and let's create a brand new C# class, which we're going to name entity extensions. Okay, entity extensions. Let me collapse this for a moment. And on this one, well, let's just fix namespace first, convert to file scope namespace, and also remove unnecessary usings. Okay, remember that all extension methods will be static, so they should live in a static class. So let's do this static, and then the method that we're going to define here is public static game DTO, and then we have to do control dot to use gamestore.api.dtos. And then as DTO, and then since it is an extension method, we have to define what exactly is that we're going to be extending. So we're going to say this game. So we're going to be extending the game entity, right? With a brand new method that's named as DTO. And then the name of the parameter is just going to be game. Okay, so with this in place, we want to go ahead and do the proper mapping. So let me just actually transfer DTOs on the right side so we can see better. Okay, so really what we want to do here is just create a brand new instance of the DTO based on the values of the game. So we're going to say return new game DTO, right? And then for the parameters, the first one is going to be the ID. So we get the ID from game.id, and then we go for game.name, and then game.genre, game.price, game.release date, and game.imageURI. So now we have a very handy extension method that we can use anytime we need to convert a game entity into a DTO. And so a quick note on this, I know that we could be using also here AutoMapper or many other of these mapping frameworks that are available today. And that's totally fine. So feel free to use that if that works best for you. But in this case, things are super simple right now. And in general case, I have found that you don't really need to introduce another framework for something as simple as doing a conversion as we're doing here. So an extension method is very straightforward, it's very easy to reason about, very easy to create. And so this is the preferred approach that I have these days, as opposed to using any other mapping framework. But it's just a personal preference, of course. So now let's see how we can use the DTOs in our endpoints. So let's go ahead and open up our Explorer and let's go into endpoints, games endpoints over here. All right, and perhaps I'm going to just move everything into our main tab now. Okay, and we're going to be focusing on games endpoints. So what we're going to do now is let's start using them, right? So for the first endpoint, the one that gets all the games, let's do this. So let's send this repository get all to the next line. And what we're going to do is that after we get all of the games, the entities, we're going to be using link with the select operator here, so that we transform each game into game.asDTO. Okay, that means that for each of the games that come from get all, we're going to transform the entity into the corresponding DTO object, right? So that way we're not returning entities anymore back to the client, but only DTOs. Same idea for map get by ID. Instead of returning the game over here, we're going to say game.asDTO. Now let's keep going down into our post method here. And the thing here is that now we have to look into the parameters we're receiving. So now we don't want to receive the game entity anymore. We want to receive the corresponding DTO. So let's rename this into create game DTO. And let's just name it game DTO, right? And for this, we have to do control dot so we can start using gamestore.api.dtos, right? So let's start using that. And now we have to figure out how to actually create the entity, because now we don't have the entity. We cannot just send it over directly to the repository. We have to create it on the fly. So let's open up one more line here, and we're going to do the same thing, the following thing. So game equals new. And here we can go ahead and define all of the properties for our entity. So we'll say that name equals game DTO.name, and then genre game DTO.genre, and we'll just keep going with this, of course, until we complete all of the properties. So game DTO.price, release date, and finally image URI equals DTO image URI. And with that in place, the rest should be the same. So now we are creating the entity directly inside the endpoint, and we send that new entity inside our repository, and we return the generated ID. So let's see what we need to do now for the put endpoint over here. So just like with the other endpoint, we are not receiving the game directly here. We have to receive the update game DTO. Okay, and perhaps we rename updated game into updated game DTO. Let me do F2 here. So updated game DTO. Okay, and here let's see. So we are retrieving the existing game from the repository as an entity, and then all we have to do is really just the same logic. So existing game, name, genre, price, release date, and image URI. We just take the values from the DTO as expected, and then we just send back that existing game into the update API of repository so that it can get updated. And then for our last endpoint, in terms of it, we don't have to do anything special here because there's no DTO involved, right? So there's nothing other than the ID to be received here, and there's nothing to be returned. So we are pretty much done there. And so with this in place, we can go ahead and test this out and see if it keeps working. So again, the behavior should be exactly the same at this point, because we have no difference between the entities and the DTOs so far, but this could change in the future, of course. So I'll do Ctrl J, and then I'm going to go into my terminal over here. I'll do .NET Run, and then I'll go into Postman, and I'll try out my get all endpoint here. I'll click on Send, and as expected, we are getting the values just like before, same idea, but of course now the properties are all coming from the DTO, the game DTO. And if we try out our post endpoint, so over here, where we have our body, of course, for the Minecraft game, we'll click on Send, and we can verify that, yeah, it was created successfully. We can see that it now shows up in our get list of games right there. And we could even verify that the validations are working properly. So let me just clean up the name of Minecraft over there. See what happens if I try to do a send. And as expected, we are getting a bad request because the name field is required. So yeah, everything is working as expected now using our DTOs. So that's the end of this model. And in the next model, we will start looking at how to use something very important, which is the .NET configuration system to do things like, for instance, accessing our SQL Server. In this model, you will stand up a SQL Server instance in your box, and you will learn how to connect your REST API to it via the .NET configuration system. By the end of this model, you will have a solid understanding of the following: how to stand up a SQL Server instance using Docker, how to use the .NET configuration system to read application settings in a web API, and how to use the .NET Secret Manager to securely store application secrets. In this lesson, you will get a quick introduction to Docker, and you will learn how to use it to stand up infrastructure services needed by your REST API like SQL Server. So what is Docker? Docker is a platform that provides the ability to package and run an application in a loosely isolated environment called a container. Here's how it works. Here's our web API, which, as we know, needs a database to store and query for games. The piece of software that knows how to stand up and operate this database in our case is SQL Server. That piece of software, along with all its software prerequisites, has already been packaged in what we call a Docker image. And this image is publicly available in a place called Docker Hub. We want to download and run this image in our box, and to do that we use the Docker engine, which comes with Docker Desktop, one of the pieces you installed at the start of this course. All Docker images are guaranteed to run anywhere the Docker engine is available. To download this image to our box, we use the Docker pull command, and to run it, we use the Docker run command. Once the image is run or executed, it becomes what is known as a Docker container, a SQL Server container in this case. This is a fully working SQL Server ready to respond to the requests of our web API. The web API will create a database via the SQL Server Docker container, and it will start interacting with it via Entity Framework Core, which we'll cover soon. Notice that even when this container manages the game's database, the database itself does not live inside the container, but outside of it, to ensure it is not deleted once the container is destroyed. Let's now go back to our development environment and stand up our SQL Server Docker container. In this course, I'll be using Docker to host the local SQL Server instance that my REST API will use to connect to. But in your case, if you already have a running SQL Server instance that's either installed in your box or that is available somewhere else in your network, feel free to use that and just skip this lesson and move to the next one where we'll learn how to connect to that SQL Server instance. For now, here I'm going to show you how to stand up SQL Server using Docker. So here I am in the Docker Hub page, which you can get into by going to hub.docker.com, and here is where you're going to find hundreds and hundreds and hundreds of publicly available Docker images for many pieces of software. One of them is SQL Server. And here, what we want to do now is to find that SQL Server image to see how exactly we're going to be using it. So to do that, I'm just going to go into my search box over here, and I'm going to type Microsoft MS SQL Server, and I'll just hit enter. And usually it should be the very first entry here. So notice that this is Microsoft SQL Server, Ubuntu-based images, and this is by Microsoft. So there are going to be a few other ones, but this is the one that I'm interested in. Okay, so this is the one officially published by Microsoft. So I'll click on that one, and this page is going to show us a bunch of information about this image, including how exactly we're going to be pulling it down into our box and running it. All right, and so let's scroll down a bit, and as you can see, here we have kind of a command line example of how you can go ahead and run the image in your box. So what I like to do is to use this as a starting point for the actual command line that we're going to be running in our box to execute the Docker image. So now let's go back into VS Code over here, and what we're going to do is to actually create a README file for our repository here for our REST API, so that we can write down those commands to execute the SQL Server Docker image, just so that we keep them handy in case that we want to restart the Docker container later on. So just at the root of gamestore.api, I'm going to right click and I'll say new file, and this file is just going to be readme.md. Okay, so let's just put some title here. So it's going to be the Game Store API. And now let's go ahead and open up a section in this README file to declare those commands for running the Docker image. So I'm going to do a subtitle here, starting SQL Server. Okay, and I'll be running mostly this in PowerShell. So that's why I'm going to just put this as a PowerShell section. PowerShell. You could do the same thing in other command lines. And here's where we're going to go ahead and bring in that command. So going back into the page, I'm just going to go ahead and copy this. So I'll select this entire section here, copy. Okay, and we'll paste that. Let me collapse this for a moment so we can see better. Now we're going to be changing this command line a little bit so that it works much better for us. So what does this mean actually? So here we're using the docker run command, right? Which means go ahead and run the image, right? Which, by the way, is going to first pull down the image into your box, and then it's going to go ahead and run it, right? So it will do those two things. And then what it's doing is defining a set of environment variables, right? For things like accept EULA, right? Where you want to say just yes, there's no need for prompts for us. So that's the first environment variable, which is specified with -e. And then there's another -e for the password that you're going to be using for the SA user. Now, for the password, I would not like to have our password just hard-coded here at all, because it's not really a good security practice to introduce passwords in our code base at all, right? So that's a big no-no once again. So what I want to do is, instead of this, let's define a variable here that I'm going to just name SA password, all right? And I'm going to say this equals, and here is where we're going to be placing that password. I'm just going to say for now, SA password here. Okay, and later on when we put this into the command line, that is where we're going to be defining that variable, and that's the variable that we're going to be using. So here in MS SQL SA password, we're going to replace this with SA password. Next parameter with -p is the port. So this is the port that we will expose in our host machine, the actual box where we're working, so that we can talk to the SQL Server instance that is running inside the container, right? You cannot just talk to it just like that. You need to open kind of a window so that you can actually start talking to the container that's running inside. So by default, that container is going to be running inside using port 1433. So we will expose on the outside, so in our host machine, we will expose port 1433 so that we can talk to that port. It doesn't have to be the same port. You could use any other port on the outside here. But by convention, to keep things simple, we'll just use that same port. The next parameter here, -d, is used to run in detached mode. That means that once we run the image, we will not just keep looking at the logs of that image as they come out. We will just return to our command line. We'll just see a little GUID string, and then our terminal is going to be free to use, right? So, and that's usually what you want to do. You don't want to be looking at all the logs from SQL Server all the time. And then lastly, what you see here is just the name of the repository and the tag of the image that we'll be using, which, as you can see, is going to be Microsoft SQL Server, and we will be using version 2022, the latest version of 2022. Now, there are a couple of other things that we want to do in this command line. And the first one is to define what is known as a volume, a data volume. We want to do this to make sure that the data files for the SQL Server database that we're going to be creating are stored outside of the Docker container and not inside. That's important because otherwise, when you stop or destroy that Docker container, those data files will be gone with the destroyed container. And you usually don't want that. You want that data to persist between instances of the Docker container, right? So for that, what you do is you create a volume and you say where you want to start your volume, store the volume inside your host machine. So for that, what we're going to do is just, let's say, just after our -p for the port, we'll say -v, right? And we'll just give it some random name to our SQL Server volume. Let's just name it SQL volume. And then we'll do colon, and after colon, we will point to the location inside the Docker image or the container where SQL Server by default stores those data files. And that location, at least for a SQL Server Linux image, is going to be under var opt/mssql. Okay, perhaps I'll put this in the next line for a few moments so you can see it better. So this is how it should read. So the data files are going to be stored in SQL volume, which is a logical name for the space in your host machine where those files will live. And it will map to the internal var opt/mssql location inside the Docker container. And I'll just do Ctrl+C so that it is a complete line. The next thing I'm going to do is to specify just after -d, I'll add a couple of other arguments. Actually, just one more argument, which is -rm. So this stands for remove. That means that anytime our Docker container is stopped, it will be automatically removed. Now this is optional, but if you don't do this, anytime you stop the container, either because you stop it manually or because you restart the machine, it's going to be a little bit more troublesome to restart the container because it just stays there in a stopped state. Right, so I find that it's better to just go ahead and remove it, and then next time you need it, you just restart it with the same command line that we are running right now. And lastly, let's add one more argument for the name. So otherwise you will get some random name for your container. So you usually want to have some more meaningful name so it's easy to identify. So the name is just going to be MSSQL. And so with that, we're pretty much ready to stand up our SQL Server Docker container. So what I'm going to do is just open my terminal. And the first thing that I'd like to do is to double check, make sure that Docker is actually running in my box. For that, I'm just going to do docker -- version. And as you can see, we are getting a version back. And then just to double check, I'll do docker ps, which is usually the command that you use to list all of the Docker containers that are running in your box. So at this point, both commands are replying successfully. And so this means that Docker is running properly. Remember that Docker will not usually auto-start when you start your machine, at least not on Windows. So make sure that Docker Desktop is running in your box and go ahead and start it right now if it is not running currently in your box. So with that verified, what we can do now is just to, well, the first thing is going to be to set up our SA password. So I'll just paste that here and I'm just going to come up with some random password. So I'll do this one. Right, so I'll hit enter, and now we have our SA password variable. Notice that this is the way that you define a variable in PowerShell. If you're using something else that's not PowerShell, you may need to do this in a slightly different way. And so now I'll just copy this other line, I'll paste it over here, and that's going to be using that password, and now I'll hit enter. Okay, and so as you can see, the Docker CLI is not able to find the image in my box. So what it's doing right now, it is downloading all of the layers that compose that Docker image from Docker Hub into my box. And after it downloads all of them, it is going to go ahead and run the image in the box. And we can verify this by doing the following. You can now do, again, docker ps, and you're going to see that now we have our SQL Server Docker image running, and you can even see the name that we specified for that Docker image over here. So this is our Docker image. This SQL Server is up and running in the box. Now, the next time that you run your Docker image is actually going to be much faster because it has already been downloaded for you. So for instance, if I now do docker stop mssql, right? So that stops the Docker image and actually removes it from my box. And then if I do the same command again to run the Docker image, notice that it is done. Right, it is done because all of the layers are already in your box. It is cached, so it is much faster, right? So that's one of the great benefits of using Docker. So now we should have a SQL Server running in the box. So what we likely want to do now is to just connect to it and verify that it's actually up and alive in your box. So for that, what I'm going to do is using the SQL Server extension for VS Code, which you can use to easily connect within VS Code to SQL Server. So I will go ahead and open my command palette via Ctrl+Shift+P right now, and I'm going to toggle my activity bar, which so far I've been just hiding. So I'll click on View, Toggle Activity Bar Visibility, and then I'm going to go into my extensions view over there. I'll just click on that one, and here I'm going to be looking for SQL Server. So it should be the very first one here. It is the one created by Microsoft. So this extension over here. Okay, I'll collapse this. This is the one that you want to install. And so, yeah, I'll just go ahead and click on install. That should take just a few seconds. All right, so it is ready. And so notice that we now have a brand new icon on the left side over here. And that's how you can access all the SQL Server tooling. Okay, so I'm going to click on that one. Okay, and that's going to initialize extension for us right now. Should just take a second. And so yes, a little bit of a warning here. We're not going to look too much into that one, so I'll just close that. And then I'll close this. And then perhaps let's also close this and that and the terminal. So now what we can do is to add a connection to our SQL Server. So for that, you can just click on this button here that says Add Connection. And for the host name, since the SQL Server instance is running in a local machine, in a local host, inside Docker, you can just specify here localhost. All right. Again, if this would be another instance that you have running in your box or in the network, you will specify that host over here. So I'll hit enter, and then we are prompted to introduce the database name, but we don't have a database right now. So we will just hit enter to move on to the next step. And then authentication type, we want to use SQL login right now. And the username is going to be our SA user, hit enter. And for the password, we will use that same password that we specified in the command line a moment ago, right? So I'll just type it here. Enter. Do we want to say the password? Yes, why not? And then this is an optional setting. Do you want to specify a display name? I don't really care, so I'll just hit enter. Okay, now here's a warning here about SQL Server and encryption. And the thing is that by default, encryption will be enabled to connections to SQL Server. But the thing is that we have not set up a proper certificate, right? A fully fledged certificate for our SQL Server instance. And that is fine because this is a local instance of SQL Server, right? So it doesn't really matter too much. And we can let SQL Server use a self-signed certificate to run our SQL Server databases, right? And so in order to do that, to use a self-signed certificate, what you can do is just enable the Trust Server Certificate setting that's prompting us to use here, so that SQL Server is happy by using that self-signed certificate, right? And will not complain about that. Okay, so this is fine for the local development environment. It will not be good for a production environment, but we'll talk about production way later in the course. So let's go ahead and click on Enable Trust Server Certificate. Click on that. And a SQL Server connection has been created, as you can see on the left side. So now if we just expand this a little bit, databases, we're going to see that we do have our system databases up and running right there. And so this means that we have successfully provisioned our SQL Server. So that's it for this lesson. And in the next lesson, we'll learn how to connect to our SQL Server instance using the .NET configuration system. At this point, we need to figure out a way to connect our .NET REST API to SQL Server. And as you may know, the way that you do that is by defining a connection string. And the connection string includes all of the parameters needed to connect to the database. Now we could go ahead and define the connection string directly in program CS here. We could just define it here. However, that's usually not a good idea because the connection parameters are usually going to change across different environments, right? Like from your box into a test environment or into a prod environment, those parameters are going to change. And so that's going to mean that you're going to be doing a bunch of things in your code here to accommodate for different environments, right? And that's not really a good idea. The best thing that you can do in this case is actually to use the .NET configuration system. And there are multiple ways to use the configuration system in .NET, but one of the basic ways to do that is by using these files here, appsettings.json and appsettings.development.json, which is the developer version of the same file, right? And like I mentioned before, this is the file where you can define a series of configuration settings with different values that you can later on read from your code files. And later, when you move to a different environment, you can find other ways to provide those same configuration values into your code without having to change your code. Now, to define a connection string using appsettings.json, there's actually a well-known section that you can use here that ties very well to the configuration system APIs that we're going to see in a second. So in this case, what I'm going to do is just define a section here that's going to be named connection strings. And notice that it's actually offered here as per IntelliSense. So I'm going to click on that one. And it has to be named connection strings, right? So that we can use it the way that we're going to be using it in a moment. So make sure that you name it exactly like this. And here what you want to do is to define two things. The first thing is going to be the name of your connection string, right? And you could use any name here, but since this is going to be for the database context that we're going to be defining later on with Entity Framework, and this is for the Game Store application, here we're just going to name this Game Store Context. And then on the right side, we're going to be defining the actual connection string. So let me just collapse this. And then how do you define this connection string? Well, the first thing they want to define here is the server name. So in my case, the server is going to be just localhost. Just make sure to use your actual server here, depending on what SQL Server instance you're using. And then the database is going to be named Game Store, right? Because that's what our application is all about. And we don't have that database just yet, but that's going to be the name that we're going to be using. And then the user ID is going to be SA, the standard system administrator of SQL Server. And then the password is going to be, well, I'm not going to be typing it here, so I'm just going to leave a placeholder for now. Password goes here, and I'm doing this because I'm going to show you another technique in the next set of lessons where you're not going to be needing to worry about this password anymore. So for now, let's just do that. And then lastly, you want to specify one more parameter that is called trust server certificate equals true. And you want to specify this parameter because of what I mentioned in the previous lesson, which is the fact that SQL Server will be using encryption. It has been enabled for encryption, but to use encryption, you have to use a certificate. And we don't have a properly prepared or fully production-ready certificate ready for us at this point, because we're just running SQL Server as a local thing, right? It's for local development environment. So in this case, we're going to let SQL Server use the self-signed server certificate that it comes with, right? And it will not complain about it because we're going to be saying trust server certificate equals true, right? So that makes SQL Server happy, it will all work. But certainly this is not what you want to do in a production environment. And we will see later in the course how we use a different connection string for a production-based database. So that's how you define your connection string. And I'll just scroll down a moment so you can see it better. This is how it looks like, right? So that's your connection string. And then, well, how do we read this connection string? So let's go back into Explorer and into program.cs. I'll collapse this. To read the connection string, all you have to do, and I'm just going to go here, you can go ahead and use the builder object. So builder dot, and there's going to be a configuration property here. So the configuration property you can use to read all of the configuration information that is being provided by the configuration system. In this case, by appsettings.json. So here what you can do is say get connection string. And just to reiterate, in order for this method to work for you, you have to make sure that you use it connection strings over here, right? That will make sure that get connection string can find your connection string. And then you want to specify the actual name of the connection string. So for that, we're going to be using game store context. So I'm just going to copy that. Game store context is the name of our connection string. And now we have a way to read the connection string. Now, of course, we want to set that into some variable so that we can see what we actually read. So I'm going to say var con string equals to the result of that. And I'm going to go ahead and place a breakpoint right here in line there. And so we can see what is the value of const string. And so now I'm just going to go ahead and hit F5 to start debugging my application. And we should hit that breakpoint right away when the application starts. So let's see, it is starting now. And as you can see, we hit the breakpoint. And as you can see, if I just hover over the const string variable over here, you're going to see the full value of the connection string right here in the pop-up. So we were able to read the configuration from appsettings.json, and that way our code, our C# code, is not really aware of what exact value we're using. It just comes from configuration. That's going to be super, super useful as we move on with our application. So let's just stop this for now. Okay, and what we want to do now is to learn actually another technique to read configuration, because like I said, we don't want to be specifying our password right here in appsettings.json. That's kind of a bad practice. So let's move on to the next lesson where we're going to learn about the .NET Secret Manager, which is a much better option to store secrets that you can use in your application locally. In this lesson, you will learn about the .NET configuration system and how to use .NET Secret Manager to store your application secrets during local development. Let's talk about secrets management. As you know, at this point we have a fully functional web API for our game store, and we also have the SQL Server database that will store our games catalog. Now, somehow we need to get our web API to talk to the database, which of course will involve the use of a connection string with all the relevant details. We have seen that we can use the appsettings.json file to store this connection string. However, doing this is not a good idea because it would involve storing user credentials in this file, and this presents serious security concerns. For instance, imagine what would happen if you eventually decide to push your source code, including this file, to a remote code repository. If that repository gets compromised, or if someone else with access to the repo pulls your code into his or her box and that box gets compromised, your connection string might suddenly land in the hands of unauthorized people, which now will have full access to your database. And if that happens to be your production database, you can be in serious trouble. That is why you should never store any sort of credentials or secrets in your appsettings.json file. So, if you can't use this file, where can you store the connection string? Well, you gotta realize that the appsettings.json file is what is known as a configuration source. And just like that one, there are several other configuration sources supported in .NET applications, like command line arguments, environment variables, and even cloud-based configuration sources like Azure Key Vault. And the great thing about this is that the ASP.NET Core runtime takes care of combining information from all available configuration sources into a single configuration object that implements the iConfiguration interface. This configuration object is easily accessible to your web API in such a way that it doesn't really need to know where the configuration data actually comes from. Furthermore, your .NET SDK installation includes what is known as the Secret Manager, which acts as one more configuration source that is specifically designed to store secrets that developers can use in their local boxes for local development and testing. You can add your connection string to Secret Manager, and it will take care of storing this and any other secrets in your local machine's user profile directory, which lives outside of your code repository. That way, you will never risk leaking your secrets as part of your code changes, and your web API will still be able to read them as any other piece of configuration. Let's now see how to use the Secret Manager to store our SQL Server connection string. Let's see how to store and read our connection string from the .NET Secret Manager. So the first thing that you want to do in order to use the Secret Manager is to initialize it. So what you want to do is just go to your terminal over here, and then all you have to do is just use this command line here, .NET user secrets init, and by the way, I'm in the GameStore.api directory, right? The directory of your project file. So just hit enter there, and that's going to go ahead and set the secrets user secrets ID for your project. So if you go now into GameStore.api, you're going to see that this secret ID that is right now in the terminal is now also defined here as a user secrets ID in your project file. So that's the first step. So that sets kind of an entry into the Secret Manager for your secrets for this specific project. And with that in place, what we have to do is to go ahead and set the secret into the Secret Manager. And for that, we want to use the command line. But before doing that, let's go back into our README file. And we're going to also, just like we did with SQL Server, we're going to be adding the command line that we want to use to, well, actually set the secret in Secret Manager, just in case that you want to set it later on. Okay, so let's go ahead and collapse this. And I'm going to open another section here. It's going to be setting the connection string to Secret Manager, right? And again, this is a PowerShell section. Just like we did before, we're going to be capturing the password into a variable. So I'm going to repeat that line that we had in the SQL Server section over here. Okay, so that's going to be our SA password. And now comes the command line to actually set the secret. And let me scroll down a bit here. And so what we're going to do is just this, .NET user secrets set. Then we open our double quotes. And then what is the actual setting that or secret that we want to set? Well, for this, we want to remember what we said before in Explorer in appsettings.json. Remember that we had said that the connection string lives under connection strings and then game store context. So what we want to do is follow that same hierarchy of settings as we set up our secret. That way, the .NET configuration system is going to know how to properly grab that setting and use it exactly how we've been using it so far in the code. Our hierarchy starts with connection strings, right? So I'm going to copy connection strings and put it over here as the first piece of the name of the secret. And then I'll do colon, and then I'll go to the next level, which is game store context, right? So I'll copy game store context over here and I'll place it right there. Okay, and then I'll close double quotes, right? And that is going to define the name of the secret itself. Now we need to go for the value. Okay, so double quotes. And so the value, well, the value is going to be really the connection string that we've been using so far, right? So I'm going to go to appsettings.json and I'll copy the entire thing, right? So I'll copy everything here, copy, over here, paste. There we go. There, now we have our connection string. But of course, now we don't want to be using this placeholder. Instead of that, we want to do SA password. And now that we did that, we can go ahead and run these commands in the terminal. So I'm just going to go ahead and open my terminal over here, and I'm going to scroll down a little bit over there, right there. And so first thing, define the actual SA password. And remember that this is the SA password that we defined before for SQL Server, for the system administrator user. So make sure you type the correct password here. So I'm going to type mine. All right. And now that we have that in place, we can go ahead and run our command to set the secret. So I'll copy that, paste that here, hit enter, and the secret has been successfully saved into the secret store. And so to confirm that the secret is actually there, what you can do is the following. So you can do .NET user secrets list, and this should provide you the full list of all of the secrets that you have so far configured for your current project. And so now that that is in place, let's go back into appsettings.json, and well, guess what? We can go ahead and fully remove this connection string section. It is no longer needed, right? Which is great. And then if we go back into our program.cs file over here, we don't really need to make any changes, because now the connection string with the exact same key should be coming from the secret manager and into our connect string variable over here. So I'll keep that breakpoint, and I'm going to do F5 to go ahead and do a debugging session, and let's confirm that we can actually read the value from secret manager. So debugging session starts, and now let's explore our connect string variable over here. And as you can see, we are now getting our full connection string right there, now coming from the secret manager. So it is stored securely outside of the code repository, and we are able to use it right away. Notice how I didn't have to make any changes here, and this is the key about the .NET configuration system, because later on we will be changing the place where we're going to be reading this connection string from, and so the fact that it is already configured this way is going to save us so much time in the future. All right, so I'll just stop this. And so that's going to be the end of this module. And in the next module, we will learn about Entity Framework Core, which is going to be the ORM framework that we're going to be using to actually start interacting with our SQL Server database. In this module, you will use the Entity Framework Core ORM framework to start querying and modifying your database records using only C#. By the end of this module, you will have a solid understanding of the following: what is Entity Framework Core, how to implement an Entity Framework DBContext, how to generate and apply database migrations, how to implement an Entity Framework repository, and how to use the asynchronous programming model to get improved performance. In this lesson, you will learn about the object relational mapping technique and how Entity Framework Core can help you write code that interacts with your database without having to learn a new language. At this point, we want to add database support to our web API, so that all our data is persisted beyond the lifetime of the application. So, whenever a request to create a game is received in our web API, we want to create that game in the database. And when the client requests a list of games, we want to query that list from the database. However, there's a problem. The database does not speak the same language as your ASP.NET Core Web API. Your Web API is coded in C#, but a SQL Server database only understands the Transact SQL language. That means that to fulfill the request to retrieve games, your C# code needs to translate the Web API request into a carefully crafted T-SQL query and then send that query to SQL Server. SQL Server executes the query, and then your C# code has to read back any resulting rows and translate them into a corresponding Web API response. This presents a few problems. As a C# developer, you now need to learn a completely new language, T-SQL, in order to craft the required queries, and you need to learn it well to ensure that you get good performance out of it. You'll need to write a lot of additional data access code, whose only purpose is to translate things from C# to T-SQL and vice versa, and of course, deal with expected errors. Talking about errors, this approach is error-prone, since it's very easy to make mistakes when mapping things from one side to the other. And you need to manually keep your C# models in sync with the corresponding database tables, which can be quite challenging. This is where Object Relational Mapping Techniques, or ORM, can make a big difference. But what is ORM? Well, going back to our Spotify example, imagine your application has been created using an object-oriented paradigm, and therefore it includes objects to represent songs, artists, and playlists. And if you're working with a relational database server like SQL Server, there's a good chance that your database will have corresponding tables for each of those objects. Now, instead of having to write custom code to map these objects to tables each time you need to send or receive data to or from the database, you can set up a map between them so that your program can keep working with objects while another component, an object relational mapper, takes care of transforming objects to tables and vice versa. So, in essence, Object Relational Mapping is a technique for converting data between a relational database and an object-oriented program. And as you can imagine, it brings many benefits to application developers. And fortunately, ASP.NET Core includes a great ORM framework called Entity Framework Core. So What is Entity Framework Core? It is a lightweight, extensible, open source, and cross-platform object relational mapper for .NET. Entity Framework Core will sit between your Web API and your SQL Server database. Besides mapping your .NET objects to SQL Server tables, it will translate your C# data access code into transact SQL statements that the database server can understand. And it will also translate any resulting data from the database into objects that your Web API can easily manage. Using Entity Framework Core in your .NET applications brings in multiple benefits. There's no need for you to learn a new language. You can perform all data access tasks using your familiar C# language. The actual data access code that you need to write is minimal, since Entity Framework takes care of most of it. In fact, you can use Language Integrated Query or LINQ to perform most of your database queries. There's tooling available to keep your C# models in sync with your database tables, so you don't need to do this manually anymore. Entity Framework can keep track of the changes made to your C# object instances at runtime, so it knows what changes to send to the database when it's time to persist the data. Also, Entity Framework Core supports multiple database providers, so you can use your same C# models with additional relational databases if needed. Let's now see how to use Entity Framework Core to add SQL Server support to our Game Store Web API. Let's see how to add Entity Framework Core support into our .NET REST API. And the first thing that we're going to need is a brand new NuGet package that will bring in the SQL Server provider for Entity Framework into our codebase. So let's go ahead and open our terminal here. And let's go ahead and, while being in the GameStore.api directory, let's do .NET add package. I'm going to collapse this for a moment so we can see better. The package that we want to add is Microsoft.Entity Framework Core.SQL Server. So I'll hit enter. And just like this package, there are other packages for other providers like SQLite or PostgreSQL, but in this case, we're using the one for SQL Server. So that is done, right? And what you should see in your project file at this point is that you have this brand new project reference or package reference, this one over here, SQL Server. And so with that in place, let's go back into our Explorer. And what we want to do now is to define a brand new directory to enter or to specify all of the classes related to Entity Framework. So I'm going to actually right click in the GameStore.api directory, new folder, and I'll put a folder named data. And in this data folder, we're going to be creating one class that is known as the DBContext or DBContext. So new C# class, and let's name this one GameStoreContext. And so I'll collapse this, and then let me arrange this by doing control dot, convert to file scope namespace, and then control dot over here to remove unnecessary usings. And this class, in order for it to become a DBContext, it just has to inherit from the DBContext class like that. Now I'll do control dot, and we want to use Microsoft.Entity Framework Core. Enter. And now our class is a proper DBContext. Now, a DBContext instance represents a session with the database and can be used to query and save instances of your entities. Also, this DBContext is kind of a combination of the unit of work and repository patterns. And so a quick note here. So you may be wondering, well, if the DBContext can act as a repository, why do we have already a repository defined for our application, right? So remember, we already have our iGames repository interface and our in-mem games repository. And of course, we're going to have an Entity Framework version of the repository later on. So why do we do this? Well, the thing is that we don't want to tie our games endpoints class over here to as a specific implementation of a data access technology, right? So we could later on just inject GameStoreContext directly here, right, as opposed to our iGames repository. But that would mean that our endpoints are coupled now into Entity Framework directly. And if later on we want to move to something else, let's say we want to move to a NoSQL database because it is, I don't know, it is more performant, or we need to scale really massively our application, we would not be able to do that without having to make a bunch of changes all over the place in our game's endpoints. But since we do have our own repository interface that we define and we control, we are not subject to that. Right? So it doesn't matter what kind of changes we make later on into our data repositories, that's never going to make or have any impact into our game's endpoints here because we're using our own interface. So that's the reason why we keep all Entity Framework stuff directly inside our GameStoreContext here, and we'll see later on how we introduce our own Entity Framework repository. Now, for this GameStoreContext instance or class, what you want to do is to define a constructor. So I'm going to do CTUR. And so on, this is a standard stuff for entity framework. What you want to do is to define just one parameter here that is known as DBContext options. And for the type argument of the context options, you want to specify your actual game store context. So just game store context like that. And then the name of this is going to be just options. Okay, and we will go ahead and send those options into our base class, into DBContext. We just send the options. Okay, so that's going to allow this game store context class to grab all the details on how to connect to the database, including the connection string. And so the next thing that we're going to need here, and let's just leave that to the side, scroll down a bit, is a property that defines our game's entities in the database, right? So for that, we're going to be declaring the following property. So it's going to be prop dbset, and then this is going to be of type game, because game is the entity that we will be managing here. And then the name of this property is just going to be games. And so let's head into our game declaration here. I'll do control dot, so we can start using gamestore.api.entities, first entry there. And then of course we're getting a warning here, right? Because we have defined a property here that is not nullable, but we have not defined any default value for this property, right? So we have not defined a default value either in the constructor or as a default value for the property. So we need to define something here. And what you can use here is actually a direct implementation in the property by just doing arrow function here, like a little arrow, and then you will define this as a set of game, right? And so that is going to define the initial dbset instance for our games property of the DBContext. And that's what we're going to be using for querying the data of our database. So with that, we have our initial basic implementation of our game store context, which we're going to be modifying in a moment in another lesson. But for now, this is good enough. What we want to do now is to actually register this game store context with our service container, just like we did with the repository. So for that, let's go ahead and do Ctrl+Shift+E to go to our Explorer. Let's go into Program.cs. And remember that we have already defined how to capture that connection string. So that's great. So that's exactly what we're going to use to define or to register our game store context. So for that, we're going to be doing the following. So builder.services. Okay, the same collection of services that we used before for the singleton. But this time, we're going to be using it to define add SQL Server. So this add SQL Server extension method here is one that is going to allow us to register the game store context with the connection string for SQL Server, right? So I'm going to specify as a type argument here, game store context. All right, and for that we'll have to do control dot, and we want to use game store.api.data, this one over here, and then we will pass in the con string as the one parameter over there. Now keep in mind that this add SQL Server method here is nothing more than doing something like add scoped. But in this case, instead of we specifying that we want to use add scoped, we are letting the creators of the entity framework SQL Server package to provide us with this extension method as SQL Server, and inside that method they will do the add scoped call, and they will construct those options that we saw here. You see these DBContext options, right? So they will construct our game store context instance with those options using the connection string that we have specified here, right? It's just a little bit of syntactic sugar, but it's super useful because now we only have to make this one call and the rest will be configured for us. And so with that, we're pretty much done with this lesson. And in the next lesson, we will learn how to use database migrations to define the mapping between our DBContext and our SQL Server tables. It's time to define our first database migration, which in Entity Framework Core terms, all it means is that we have to define how we're going to go from one state of the database into another state of the database, potentially going from nothing into having our actual games table, going from the entities that we have defined already in our DBContext. And the migration is also going to define how we can go back from the current state into the previous state if we ever need to. Now, to define a migration, the first thing that we're going to need is a tool from the Entity Framework team, right, that we're going to be using for performing the actual migration. So to do that, let's go back into our terminal. So I'm going to do Ctrl+J here to open my terminal. And the tool that you're going to need is named, so, well, you want to do this, .NET tool install. That's how you install .NET Tools in your box. And this tool is going to be installed globally so that you can use it in any of your projects, right? So we're going to say global. And then the tool name is .NET EF. So I'll hit enter, and that's going to install the tool globally into my machine. So that's the first thing. The second thing that you're going to need is a brand new NuGet package that is going to enable Entity Framework to actually scaffold the migrations that we're going to need, because we're not going to be creating them manually. They're going to be generated by the tool. So let me clean this. And what you want to do is the following. .NET add package. And let me actually collapse this so we can see better. The name of the package is Microsoft.entityframeworkcore.design. All right. So I'll hit enter. And that will install the package. And just to confirm, you want to go into gamestore.api.csproc. And now you should see that you have this brand new package over here. This package reference is what confirms that the package has been added into your project. So with all this in place, we are ready to generate our first migration. So I'm going to open my terminal here, and I'm going to clear this. And to generate an initial migration, what you want to do is the following. .NET EF migrations add, and then we want to provide some name for this migration. Let me actually collapse this. The name for this migration, and you can put any name here, but since it's the very first one that we're going to generate, so let's just name it initial create. And then you want to specify where is that you want to generate the files, right? In our case, what I'd like to do is just to generate those files inside our data directory over here on the left side. And so because of that, I'm going to say -- output dir is going to be data, and inside data, let's create a directory called migrations. So I'll go ahead and hit enter. What this is going to do is going to go ahead and build your project, and then it is going to be using your database context to define how exactly we're going to go from nothing to an actual games database in the SQL Server. Now, as you can see on the Explorer here, we do have now our migrations folder, and we do have our initial migration. And we're going to take a look at this warning in a second. I will go back to that. But for now, let's see what got generated. So as you can see, the main thing that got generated here will not go into all of these files, but the main one is this one here, which likely is going to have another timestamp here, depending on when you're running this migration. But the main thing is that it is named initial create, right? And if we can see here, if we go down, you're going to see that this is a class named initial create, extends from migration, right? And it will have two methods, right? The first one is going to be the up method, this one over here, up, which means that this is a method that's going to be used to go from the current state of the database into the new state. And for that new state, it is saying here that it is going to go ahead and create a table whose name is going to be games. And then it is going to have the following fields. It's going to have an ID field, which happens to be that it's going to be a SQL Server identity, meaning that it is going to be auto-incremented anytime we insert rows into the database, right? Which is what we want. And it is of type int, and it is not going to be nullable, right? So it has to have a value. Okay, and just like that, we can keep going with the other properties. Like we have the name here, which is of type string, right? But in SQL Server, it's going to translate into nvarchar of 50 because we defined that the name property can only have up to 50 characters. Remember that we did that in the data annotations of the entity, the game entity here. Remember that name has this constraint, string length 50. Because of that, in our migration, it decided that nvarchar was going to be 50. So that is why it is important to clearly define what is going to be the length of your entities in the properties. Okay, so max length 50, and again, it is nullable false. And then same idea with genre, and then with price. In this case, it decided or defaulted to a decimal of 18,2, right? So precision 18, scale 2. And of course, this means that we could have up to 18 digits in this decimal, where 2 of them can be can go after the dot, right? So as part of the actual decimal numbers. And then, so that's going to be nullable false. And then release date, it translates into datetime 2. And then lastly, image URI is an nvarchar of 100, right? Also nullable false. And it defines also the constraint, right? So it's going to be a primary key, right, of PK names on the ID. And this is just by convention, right? So it decided by convention, it decided that since we have an ID field, that is going to be the primary key. And also that's why by convention, it decided that it will go ahead and auto increment that one field because it is named ID, right? It's just one convention. And yeah, that is the up method. And then in the down method, what you can see is that it's going to revert that. So if we ever have to go back into the previous state, the down method will kick in and it's going to go ahead and, of course, just go ahead and drop the table, because that's what's going to take us to the previous state. So yeah, that's going to be our initial migration, but we did see that there is a warning here, right? What does this warning say? Well, it says no store type was specified for decimal property price on entity type game. This will cause values to be silently truncated. And so yeah, what this really means is that for our price, right? So notice this here, for price, it automatically decided to just go with decimal 18,2, right? But it doesn't really know if 18 with scale 2 is going to be enough, or is going to be what we expect when we send our decimal values for the prices into the database. So it is warning us, saying, hey, I don't know if this is going to work for you, so I'm warning you. You might as well just specify this very clearly, what exact value you want in SQL Server, or what exact type you want in SQL Server, right, for your price. So that is the warning that we're seeing here. And so in the next lesson, we're going to see how to do the right thing so that we don't have to deal with this warning anymore. We ended the previous lesson with this warning that we have on screen here, that is related to the fact that we have not specified which exact precision and scale we want to use for our price column in SQL Server. So in this lesson, we're going to see how to use what we know as an entity type configuration to clearly tell SQL Server what precision and scale we want to use here. So what we want to do now is let's just close this terminal and let's go back into our Explorer, and I'm going to also close this and the migrations folder. And what we want to do is to create a brand new folder just under data. So under data, new folder, and let's name this folder configurations. And in our new configurations folder, we're going to be creating a brand new class that we're going to be calling. So let's just right click, new C# class. The name is going to be game configuration. Let me collapse this for a moment. And once again, let's go ahead and convert to files called namespace and remove unnecessary uses. Now, in order to make this game configuration class an actual entity type configuration, we have to implement one interface that is named iEntity type configuration. And then for that one, we'll have to do control dot, and we want to use entity framework, Microsoft.entity framework core. So hit enter. So we use the right namespace, and then you have to specify a type parameter here, which is going to be the type of the entity that has the column or columns that you want to configure. So in this case is game, just game. And then for that one, we'll have to do control dot once again, and we can use gamestore.api.entities. And with that in place, what we want to do now is to implement this interface. And for that, you can once again go into these curly braces, and you can either use the light bulb, or you can do control dot, as I'm doing now, and select the first option that says implement interface. Okay, so implement interface, that's going to scaffold this one method here is the only method that we have to implement in order to satisfy the interface. And in this method, what we're going to do, and let me scroll down a bit here, what we're going to do is just one simple thing. We're going to define exactly what's going to be the precision of our price column. So for that, what we can do is the following. So we're going to say builder.property. And in this property, we're going to be defining kind of an expression. So in this expression, we're going to say game, and then arrow function here, game.price. And for that price, we're going to go into the next line, and we're going to say dot has precision. Okay, and here's where we can specify both the precision and the scale that we actually need for our price column. Now in our case, like we said, I mean, the default is 18 with 2 decimal places for scale, but that's way too much. We know that our prices should not exceed like $100, right? As per our restrictions. So let's go ahead and say, well, precision is going to be 5 and scale is going to be 2, meaning that we should be able to get up to a number that is perhaps 999, and then with 99 as decimals, right? Which is still too much, but it should be good enough. Let's just leave a little bit of room just in case, right? So this should be good enough. And now that we have our game configuration defined, we have to tell the context, the DBContext, how to use this configuration. So for that, let's go to Explorer and let's go to game store context over here. And what we're going to do is just to override one method from the base class, from the base DBContext class, that is going to allow us to apply our configuration. So let's go down here and let's say protected override void, and this is going to be on model creating. Okay, and the parameter is going to be model builder. Okay, so we will be overriding that method. And what we're going to do here is just to use one and single method to apply every single configuration that we have defined in our project that implements the right interface, right? Remember that game configuration implements entity type configuration. So this method we're going to be using is just going to be looking for every single class that implements that interface, and it's going to be applied into our DBContext. So model builder dot apply configurations from assembly. And what assembly is going to be? Well, it's going to be our executing assembly. So assembly, and then for that one we'll have to do control dot, and then we will use the very first option using system.reflection. Okay, assembly dot get executing assembly, right? So that will give us the current executing assembly of the line that where we are right now, which is just a single assembly for our web API. And so what this is going to do, like I said, is that whenever the model is getting created as part of the migration, the context is going to tell the migrations tooling that we have to apply that configuration that we have defined. So let's now go back into our Explorer, and what we're going to do is just to delete our migrations folder, the migrations folder we have over here. We're just going to go ahead and delete it because we're going to be regenerating it completely, right? So I'm just going to say move to recycle bin. Okay, so it is gone. And now we can go back into our terminal, and I'll do CLS. And then we can go ahead and do the same command that we did before, right? So if you remember .NET EF migrations, add initial create and the output dir, and that will go ahead and regenerate the migration for us. So I'll hit enter. And I'm going to go ahead and build it. And then as you can see, there is no more any warnings here. So it's all clean, right? And if we look at the migrations folder, we have a brand new initial create over here. Let's collapse this and that. And let's see if everything worked properly. Notice this over here. So this one over here. Notice that now it is not defaulting to 18,2, it is now 5,2, which is the exact precision and scale that we want. And it's also defined over here, precision and scale. So now SQL Server knows exactly what type we want to use for decimal, and now it doesn't complain anymore. And now that we have this ready, let's move on into the next lesson where we're going to see how to actually apply this database migration into our SQL Server instance. With our database migration ready, it is now time to apply this migration into our SQL Server instance. And doing that is actually very, very straightforward. So let's go back into Visual Studio Code here, and I'm going to go ahead and open my terminal. And again, I am in the directory of gamestore.api. What I'm going to do is just run the following command: .NET EF database update. I'm actually going to go ahead and collapse this so we can see better. Okay, so by executing this command, we are going to run those statements in the migration into our SQL Server database. So I'm going to go ahead and hit enter. And the project is compiled. And just after that, as you can see, Entity Framework tooling will go ahead and translate what has been defined in our migrations into proper SQL Server commands. So as you can see, let's take a quick look. Over here, we have our create database statement right there. That's where the database is being created. So let's keep going down. Let's see what else is interesting here. Here we can see the creation of our table, the migrations table, right? We're going to take a look at that migrations table in a second, but this is the table that keeps track of the migration history. Okay, we'll take a look in a moment on that one. Then let's keep going down. And here you can see that the actual migration is being applied right here, right? So that's our migration. And of course that results in our table getting created in the next login line over here, right there. And finally, as the very last line, there is a new record being inserted into our migration history, which corresponds to the migration that just got executed, right? So that it can keep track of it. But of course, if all of this is succeeded, that means that we should have our table and even our Entity Framework migration history table ready. So let's go back into our SQL Server Explorer. And for that, I'm going to show up once again my activity bar right there. And I'm going to go over here. Okay, this one here is for the SQL Server Explorer. And what I'm going to do now is to just go ahead and right click on databases. And I'm going to refresh. And as you can see, now we not just have the system databases, we also have our game store database here. I'm going to collapse this. And under tables, we're going to see that we have two tables. The first table is going to be our EF migrations history, as you can see right here, and here's all the columns. And if we right click on this one and we select top 1000, right, we're going to see on the right side, it's a bit hard to see, so let me see if I can close this one. There it is. You can see that we have our very first migration right here, and with the version of Entity Framework. And so this is going to get populated with every single subsequent migration that you create, so that Entity Framework can keep track of what's going on with your migrations in your database. And the other one is going to be our games table, which is here on the left side. As you can see, it has all of the expected columns, but of course, right now it doesn't have really any data because we have not inserted any data into that table just yet, right? We'll look into that in a future lesson. Now, for now, this works just fine, but in the next lesson, we're going to see how to apply migrations directly and automatically on application startup. In the previous lesson, I showed you how to apply migrations using the Entity Framework tools. But now I'd like to show you how to do this in a different way. So how can we apply migrations automatically on application startup? And that can be very handy to simplify your application deployment later on, because you will not need to be applying over and over again each of these migrations as you make changes into your entities. So let's see how we can do this. Let's go into our program.cs file over here. I'm going to collapse this for a moment. And here we're going to do the following, just under the declaration of our app, right? So let's go here under line 11. Over here, we're going to be adding the following set of lines. So first, we're going to be creating a scope, because everything that has to do with our game store DBContext has to happen in the context of a scope. So we'll do using var scope equals app.services.create scope. That creates a services scope that we can then use to start resolving services that we're going to need. And the one service that we need here is our DBContext. So what we can do now is the following: var DBContext equals scope.serviceProvider, which is the one class that you can use to retrieve services from the service container from iServiceProvider. You can use this class over here, or this property, and then you can do get required service, and then you specify for what type. The type is going to be game store context. Okay, and now that you have the instance of the DBContext there, you can do the following. You can just say dbcontext.database.migrate. And in order to use migrate, you will have to do control dot here so that you can use Microsoft.entityframework.core. So this migrate method here is going to go ahead and automatically apply any of the missing migrations in your database, including the initial migration to go ahead and create a database. So this line over here has the same effect as using the Entity Framework tools to apply the migration as we did in the previous lesson. Now we could leave things like this, but I think that a better way to do this is to actually create a specific class to take care of this code. That way we don't pollute our program class once again. So let's do the following. Let's go into our Explorer and into our data directory, and we're going to just right click and add a new C# class that we're going to be naming data extensions. Right, so here we're going to be creating a brand new extension method that can go ahead and perform the database migration. So I'm going to go ahead and clean this out to convert to file scope namespace and remove unnecessary usings. And this is going to be a static class because it is for an extension method. And now let's go ahead and define our method. So the method is going to be public static void initialize db. And then the thing that we're going to be extending is iService provider. Okay, and the name is going to be just service provider. And like I said, iService provider is the one thing that represents the service container, and it is from there that you can go ahead and always resolve those services that have been registered during application startup. And so here we can go ahead now and introduce those lines that we created over here. And so first I'm going to grab an instance of that scope, and I'm going to do it in the following way. So I'm going to say using var scope equals service provider dot create scope, right? Create scope, And yeah, these little squiggles here, what they're saying is that there is even a better way to define this. And so to define this kind of using context. And so yeah, let's go ahead and do that. So I'm going to do control dot, and then we're going to go for use simple using statement. I'll click on that. And as you can see, now we can do this in just one line, right? So there's no need for curly braces. So that makes sense. And then now we're going to go ahead and go back into program and actually copy these lines, right? Those lines over here. Okay, for the same effect. And of course, we had to do control dot here to use Microsoft.Entity Framework Core. And with that, our extension method is ready. Thanks to that, we can now go back into program.cs. And what we can do is just say, instead of all of these lines over here, we can just say app.services.initializeDB. Right? So now we are extending the service provider instance that is defined over here. That's the idea of the extension methods. So with that done, let's go ahead and try out this new logic and see if we can actually run the migrations as the application starts up. So to verify that this actually works, what we're going to do is to go back into our SQL Server Explorer over here, and let's connect into our instance over here. And what we're going to do is just drop the game store database, right? Which is fine because we don't have anything meaningful there for now. And so we're going to drop it, and then we're going to run the application and see if the database gets recreated. So I'm going to right click on localhost over here. I'll do new query. And to drop the database, all you have to do is just say drop database game store in this case. Okay, so drop database game store. I'm going to click on this button over here. That's going to go ahead and run the script. So I'll click on that. And the database should have been removed by now. So I'll click close that. I'll close this. And if I refresh databases here, the game store database is now gone. Right? So it's not longer there. And with that in place, we can go back into our terminal. So I'll do Ctrl J to open my terminal, and I'm just going to go ahead and do .NET run, and I'm going to collapse T so that we can see better the logs. So .NET run, hit enter. And as you can see, as the application started, it went ahead and executed all of those SQL Server commands that before were executed when we run the Entity Framework tool, right? So all of these executed, including the creation of the database, it happened right there, and the insertion of the value into the brand new EF migration history table, right? And after that, the application actually started executing, right? So it looks like it worked just fine, and I'm going to stop my server for now and just go back into the SQL Server Explorer, and then I'll right click on databases, refresh, and as you can see, the game store database is back. The tables are there. We have the EF migration history. We have the games table. Everything is right there. And so now that we have our database ready, we're going to move on into the next lesson where we're going to implement a brand new repository that will be able to use our DBContext to start interacting with our brand new database. It's time to implement our brand new repository, which is going to make use of our new game store DBContext to be able to both query and also make changes into our brand new game store database. So let's go now into our repositories directory over here, where as of right now, we only have our iGames repository interface and our in-mem games repository. So what we're going to do is to create a brand new class. So let's just right click over here, new C# class. And this one we're going to be naming Entity Framework Games Repository. Right? Because this is a repository that's going to be pretty much dedicated to work with Entity Framework objects. Right? So now let's collapse this and let's fix things a little bit. File scope namespace and remove necessary usings. Now, as we know, for this class to be an actual repository, it has to implement our iGames repository interface. So we'll go ahead and do that. iGames repository right there. And then I'll just do control dot here, and I'm going to select the first option to implement the interface. So that gives us the initial code for the repository. Now I'm just going to order these methods a little bit so that they follow a similar pattern as we did with the other repository. So I'm going to have create, go after our get, and then we have update, and at the end we're going to have delete. Right? Delete. So yeah, so we have delete at the end, update, create, get by ID, and then get all. And so the next thing that we'll have to do in this repository is to define our DBContext instance. And so for that, we're going to declare private, read only, because nobody should change this instance after construction, and then game store context. And for that one, we'll have to do control dot, and then we're going to be using gamestore.api.data namespace. And then the name is going to be just DBContext. And now what we want to do is to inject an instance of gamestore context via our constructor. And so for that, I'm just going to click here on DBContext, and I'll do again control dot, and I'm going to select the very last option over here that says generate constructor entity framework games repository with gamestore context as a parameter. So I'll click on that one, and that went ahead and generated this brand new constructor that receives the DBContext as injected, dependency injection, and it assigns that parameter into the local DBContext variable that we have there. And now that we have that, it is time to start implementing all of our methods, right? So let's start with getAll. So how do we get all of our entities using our DBContext? So that's very straightforward. All you have to do is the following. You will do return DBContext.games, because that's our games collection, and then you can do toList, right? That will go ahead and return the full list of games back into the caller. Now, one thing that we want to do here as a small optimization is to make sure that Entity Framework is not trying to keep track of changes to these returned entities, right? Because that's kind of a built-in feature of the Entity Framework. It will go ahead and do additional logic to start keeping track of any changes that the caller makes to the game's entities. However, for the case of a getAll, we don't really need that because all we're going to do, as we know, is just return those entities back into the client. So there's not going to be any modifications. And so we can speed up things for this query by just asking Entity Framework to not do any sort of tracking, right? So to do that, all we have to do is just say dot as no tracking, just like that. And for that, we're going to do control dot, and then using Microsoft.Entity Framework core, just like that. And with that, like I said, there is not going to be any sort of tracking on this list of entities, and that's going to speed up the retrieval of those entities so we can send them back quicker into the client. All right, so let's keep going into our getById implementation here, which is going to be the following. So return dbcontext.games.find, and for the find method, we're going to pass in the ID. And that's all it is. Then let's go for our create method over here. And to implement create, all that we have to do is to add that instance into our collection of games. So what we're going to do is just dbcontext.games.add, and then we're going to set our game entity right there. And lastly, we have to invoke the save changes method of the dbcontext so that the changes are actually sent back into the database. So dbcontext.savechanges. Okay, keep in mind that this line here, all it is doing is asking Entity Framework to keep track of the fact that there is a new entity that is being tracked by Entity Framework in the DBContext. But that line is not adding or inserting the row into SQL Server. Only when you invoke this line here, then the changes are all sent back into the database. And then let's go into our update method over here. So for update, it's going to be very straightforward too. So dbcontext.update, and then we send over the updated game. And again, dbcontext.savechanges. And then lastly, let's go for our delete method over here. And to implement a delete, there are a couple of ways to perform this deletion, but the way that I like to do it these days is by using a nice feature which is known as batch delete. This is going to allow us to perform the delete without having to first load the entity into memory, just so that we can later delete it. With this other feature, we can go ahead and delete it right away. And so in order to do that, what you want to do is the following. dbcontext.games.where, and this is going to be our selector. So this is how we're going to select which entities are going to be deleted. So we're going to say game where game.id matches the ID that we got as a parameter. And once we have selected which entities we want to delete, we're going to say just dot execute delete. Okay, like I said, this is kind of a batch delete behavior that allows you to first select which entities to delete, which is just the one that has the ID that was passed in, and then it goes ahead and deletes everything that matches that criteria. And so, yeah, that completes the implementation of our brand new Entity Framework repository. And in the next lesson, we'll see how to use our new Entity Framework repository to see our application start querying and storing data in SQL Server for the first time. Let's see how to take advantage of our brand new Entity Framework repository in our .NET REST API. So if we go back into our program.cs file over here, we're going to remember that in line 7 over here is where we currently register the inmem games repository as the one that implements our iGames repository interface. And so the beauty of dependency injection is that now, in order to use the brand new repository, all we have to do is just switch inmem games repository into Entity Framework games repository. And just by doing that, the entire application is going to start using this brand new repository. And our games endpoints don't have to know that we're making this change. Those should just keep working as is. Now, one other important change that we have to make here is to switch this registration from @singleton into @scoped. So no longer singleton, but just scoped, just like this. And this is because, keep in mind that the GameStore context is registered as a scope service. And that's what SQL Server is going to do inside this, is going to register the GameStore context as a scope service. And that is just because of the way that the GameStore context has been designed. It is designed to really just work for a small amount of time, right, during the duration of your request. You should not keep this GameStore context just living and hanging around for the entirety of the application. So you do need a new instance of this guy for every single new request. And since our GameStore context demands to be a scoped service, and if we kept the Entity Framework Games repository as a singleton service, it is not going to be possible to just inject GameStore context into the Entity Framework Games repository, right? Which is going to be a singleton. And that's because you cannot just inject a scoped service into a singleton service, right? The singleton is expected to live for the entirety of the application, while the scoped service requires a scope, and there's not going to be any scope in a singleton. If you wanted to, you can make that work by doing just something similar to what we did in the initializeDB method over here. So if we go and do F12 and initializeDB, remember that here's where we created a scope right here using the service provider. We created a scope, and via that scope, we were able to take advantage of our GameStore context because it is scoped. It has to use a scope. And you could do that if you wanted to in the Entity Framework Games repository, but that's not really very usual. That's not what you want to do. You might as well just keep the exact same service lifetime for both the context and your games repository. Now, we could keep things like this and just go with that, but I'm not liking how much code we're writing right now just for the purposes of registering this repository and the context. And so to keep things, this file kind of clean, we're going to be writing a brand new extension method that takes care of everything related to registering the repository. So let's go back into our .NET extensions file over here. And what we're going to do is just scroll down, and we're going to be creating a brand new method that we're going to be calling public static iService collection. That's what we're going to be returning. And then the name is @repositories. Now this is going to be receiving two parameters. The first one is the type that we're extending. So this is going to be iService collection and services. It's going to be the name. And then the second parameter is going to be our iConfiguration instance. Okay. Remember that configuration is the object that you can use to retrieve any of the values that you have configured anywhere in the .NET configuration system, either appsettings.json or .NET Secret Manager or anywhere else. So let's go ahead and open and close curly braces, and let's scroll down a bit. And what we want to do now is to bring in those lines. Let's start with these two lines over here, which are the ones that we use to register our GameStore context. So I'm just going to copy that and paste those over here. And in this case, instead of using the builder, we're going to be using the configuration object that we just received as parameter, like this. And then for the actual registration, we're going to be using directly the services parameter that we also got as a parameter over there. So that's that. And then what we want to do is to also bring in our @scoped call that we have over here. So I'm going to be copying this, and we can change that into our @SQL Server call, just like that. And then for this, we may want to introduce other namespaces. So I'll do control . So we can use GameStore.api.repositories and Entity Framework Games repository. And after doing that, what we're going to do is just return the services instance. Okay, so by returning services, we allow any other of our callers to just make other calls into that use that services collection. So with that in place, if we go back into program, we can now go ahead and do the following. Instead of having these three lines, we can just say builder.services.add_repositories, and then we will pass in just builder.configuration. And that's all it is. Okay, so keep things clean, and we can actually clean up these namespaces, remove necessary namespaces, and that's all of our product.cs file at this point. And with that in place, we can go ahead and try out our .NET REST API with our SQL Server support for the very first time. So I'll do Ctrl-J here, okay? And so we're just going to do .NET Run. So that's going to start, and it is going to try to apply migrations if needed. But of course, there are no more migrations needed. As you can see right here, okay, the database is already up to date, so no more migrations. So we are ready to start using the database. So let's go back into our Postman over here, and let's see if we can actually get any gains by just querying the database right now. So I'm going to use my get all endpoint over here. I'll click on send, and as expected, there are no gains right now, right? This is completely empty. And what we can do now is to actually go ahead and create a game, right? So let's go back into our Post tab over here, where we already have scaffolded the code to create our Minecraft game. And let me actually put here Minecraft, which is where it should be. Okay, and this should go ahead and create the Minecraft game. So let's go ahead and click on send. And as you can see, it was a success. So we got our 201 created status code, and we got our payload right there. And so this means that if we go back to our get all, click on send, we have our very first game now coming from the database. And yeah, so since that is working, we could also verify that updates are working fine. So let's go into our boot over here, where what this is doing right now is just updating game number 1. But perhaps, yeah, it would not make sense to update Minecraft into Street Fighter 2 Turbo. So let's go back into Post, and let me just grab this body over here. I'm going to replace it there. And all we're going to do is just modify the name. Let's say that this is Minecraft for Windows, and the price is going to be cheaper. Let's do $9.99. So let's go ahead and send our put call. And yeah, it was a 204 success. So I'll go ahead and get all of our games, and that is working just fine. I can also get game number 1 over here by get by ID, hit send. It is getting the 1 game, so that worked just fine. And lastly, we could go ahead and also delete the game. But before we do that, let's actually create just another one, right? Just so that we have 2 items, and then we end up with just one item at the very end. So let's create one more Minecraft game over there. So now we have 2 Minecraft games, right? So get all, we have 2 Minecraft games, and in the delete call over here, we're going to be deleting game number 2. Okay, so delete game number 2, hit send, and then that was a success. We go back to get all, click send, and we only have 1 game. So the entire REST API seems to be working just fine. And of course, what we want to verify now is that everything is actually stored into the database. So let's go back into Visual Studio Code over here, and I'm going to Ctrl-C to stop my server. I'll go back into my SQL Server Explorer over here, and then I'm going to right-click on in my games table, select top 1000. Okay, and if things are working properly, we should see here, let me put this on this side, we can see that we do have our Minecraft game stored into the database. So yeah, our REST API is now fully integrated into SQL Server database. And with that in place, in the next lesson, we'll learn about an important technique that you don't want to miss in your REST API implementation, which is known as the asynchronous programming model. In this lesson, you will learn about the asynchronous programming model and how to use it to your advantage in your ASP.NET Core applications. To understand asynchronous programming, let's go through a common scenario you might be familiar with, which is making breakfast. Let's say you start by heating your pan for a few minutes, and then, when ready, you fry some eggs there. We would also like to have some bread for our breakfast, so after our eggs are ready, we bring up the toaster and toast our bread. Then, when the bread is ready, we add some jam or peanut butter on it. Finally, our breakfast would not be complete without some juice, so let's pour in some orange juice. In total, it took us about 30 minutes to complete our breakfast. But is that really how you would go about preparing your breakfast? If it is a weekday, when you're usually in a rush, perhaps you would do it this way instead. You start heating your pan, and while that happens, you will also start toasting your bread. And while those 2 things are happening, perhaps you can also pour your orange juice. Eventually, when the pan is ready, you go back to it and fry some eggs. And once the bread is toasted, you go and put the jam or peanut butter on it. Doing things this way, you can be done in much less time, let's say 15 minutes, and perhaps you can spend the rest of the time enjoying your breakfast. When comparing these two ways of going about making your breakfast, we say that the first approach is synchronous, since you won't start a new task until the previous one is complete. However, the second approach is asynchronous, since you don't wait for a task to complete before starting your next task. Instead, you start as many tasks as you can, and eventually you turn your attention to the tasks that are ready for you so you can continue with the next task. In a similar way, you can perform asynchronous programming in your ASP.NET Core applications. When a client sends a request to the web server, you want to start handling the request in your endpoint in an asynchronous way so that your cook, the Kester web server, is immediately free to start handling the next request. So as your endpoint starts an asynchronous call perhaps to your repository, and the repository in turn requests data asynchronously from the database, the web server has also started serving the next request also asynchronously. When the database eventually returns requested data, the repository will resume work and send the data back to the endpoint, which in turn returns work, transforms entities into DTOs, and sends the data back to the web server, who in turn responds to the original client request. After this, the application continues starting other tasks asynchronously and resumes work whenever necessary. As you can see, the asynchronous programming model brings in multiple benefits. Your application gets improved performance since you avoid blocking callers and free them up to perform other tasks, which also results in overall better responsiveness. You are able to scale your application better because it can handle more requests and users simultaneously without getting bogged down by waiting for I/O operations to complete. And also, the use of task objects in combination with the async and await keywords provide a simple and intuitive way of writing asynchronous code as opposed to having to deal with threads and callbacks directly. Now that you understand the asynchronous programming model and its benefits, let's see how to put it to work in our current web API. Let's see how to take advantage of the asynchronous programming model in our .NET REST API. So the first thing that we're going to do is go into our iGames repository interface, this one over here, and we're going to be modifying all of our methods so that they follow the conventions of the asynchronous programming model. So the first convention that we should enforce here is that since all of these methods are going to be for asynchronous operations, they should have a different suffix, right? So for instance, create should be renamed, and I'm going to just do F2 here, so F2. So create should be renamed into create async, right? And that's just a convention in the .NET world. You don't have to do it, but it is the right way to name any method that is going to perform any kind of asynchronous work. And so just like that, I'll do F2 for delete. So delete async, and then I'll do F2 for get async. And then for get all, I'll also do get all async. And lastly, for update, I'll do update async. Notice that I'm using F2 here because I want to make sure that these changes apply not just to my interface, but also to all of my repositories, right? So if I go into my entity frame repository, notice that the names have changed, right? And same thing for in-mem games repository, the names should have changed by now. Okay, that's what I'm using F2. The next thing that we want to do in this interface, and close that, is to make sure that all of them are returning tasks as opposed to the actual object or even void. That is what is going to allow the callers to not just block on the call into these methods, but actually take advantage of the asynchronous programming model by using the task library available in .NET. So we're going to rename all of these return types into task. So instead of void, we're going to just type task. And then again, instead of void, we do task. And instead of game nullable, we now have to say task of game nullable. And then instead of IEnumerable, we'll say task of IEnumerable of game. And instead of update async, it's going to be task update async. So with the interface fixed, now we can go and actually implement the asynchronous programming model in our repositories. So let's start with the entity framework games repository. I'm going to collapse this for a moment. So let's go up now. And of course, we now have to match the updated interface. So let's go and start doing that one by one. So let's start with our get all async method, right? So like I said, we have to return now a task, right? So this is going to return task of IEnumerable of game. And now, when we invoke the toList method of the entity framework for the games collection here, we don't want to use toList, but we want to use the variant that is for the asynchronous programming model. And you're going to find this in most libraries that are going to perform any kind of time-consuming operation, right? There's always going to be some variant for asynchronous programming. So I'm going to do Control Spacebar here to find any other overloads. So if we go down here, we're going to find that there is a toList async method right here. So I'll do that one, right? So now we're going to not be blocking in our call to toList, but instead we're going to just let the asynchronous programming model do its magic, right? So that we don't have to block on that call. Now, in order to be to start using this kind of API here, we also have to make modifications into two places in this method. First, we have to specify just after public, we want to say that this is going to be async. And also before returning, we want to say that this is going to use await. So that is that combination of returning task and using async and await for every single invocation is what's going to allow you to take advantage of the asynchronous programming model for this very specific method. So whenever somebody invokes this getAllAsync method, that caller is not going to have to block on the invocation of getAllAsync. It's just going to start the task, and whenever the task is complete, the results are going to be returned back into the client so that, or into the caller, so that it can continue the operation. Now let's keep going down into the next set of methods. So now we have our getAsync, which is going to return a task of game nullable. Okay, and now of course this has to be async, and then it has to do await here, and this is going to use find async, the synchronous version. Now let's do the same thing for create async. So this is going to return a task. It's going to be async here, and then it's going to do await DBContext.save changes async. All right, so let's keep going down. Let's go for our update operation. So this is going to return task. It's going to be async. Then it's going to be await save changes async. And then lastly, for delete, same thing. We do task, async task, and then we're going to do await, and that execute delete async. And just by doing that, now our entity framework repository has been updated to follow the asynchronous programming model. Now, just like we did this with this repository, we'll have to do the same thing with our in-mem games repository, right? So that it can actually comply with the interface. Now, at this point, of course, you could decide to just get rid of this in-mem games repository if it doesn't work for you. But I found it very handy to do a few tests later on. So that's why I'll be just keeping it around. And all we have to do is just comply with the changes required by the interface. So let's go down into getAllAsync. And again, what we want to do here is just say that this returns task of enumerable of game. And again, we want to do async, and then we want to return await. But of course, there is nothing really to await on, right? Because this is in memory, there's nothing that we're going to be calling into. So for these cases, what you want to do is just take advantage of this method called task.fromResult. Okay, and then you can just pass in your result. Okay, so this is kind of a way to say, hey, let's spin up a brand new task, but just create it using the result that is right here. There's no need to wait on anything, just return a task that includes that result. So that's going to be very handy for our in-mem games repository. So let's keep going down into getAsync, which again is going to be task of game over here. And then we're going to do async, and then await, and then task.fromResult. And then games.find, and then we'll close over there. Okay, once again, we're returning a completed task out of that found game. Scrolling down into create async, we are returning async task, create async. And in this case, since we don't actually have to return anything, what you can do is just say await task.completed task, meaning that the task has already completed. There's nothing to wait for in this method. Same thing with update async. We're going to say that this is async task update async, and then we await task.completed task. And once again, we're going to go into our delete async method here. It's going to be async task, and then we await task.completed task. So now all of our repositories have now switched into the asynchronous programming model. But now we have to make also a few changes in our endpoints extension methods so that they can also work with this new paradigm. So let's go into Explorer and let's go into endpoints, games endpoints. And let's scroll down into our first method here, which is the map get for the get all operation. So now the first thing that we want to do here is to add the async modifier, right? Just before the parameter for this method here, we want to do async, right? So that we can do an asynchronous operation inside this method. And then before invoking a repository that get all async, we want to do await right there. Okay, and then we want to close into parentheses this invocation into get all async. Okay, that way the asynchronous operation happens inside these parentheses and we get out the actual list that we can then use to select the games and transform them into DTOs. Then moving on to our get by ID, all we want to do is just do async here, and then we're going to do an await into repository get all async, and that's all we have to do there. And then we're going to scroll down into post. Once again, we do async here. And then at the point where we invoke repository that create async, what we want to do is just say await repository that create async. That will do it. And then moving down into map put, once again we do async, and then we're going to do await over here, and also all the way down into update async. This call has to also do await. And finally, for our map delete, once again we do async, and then we do await here and also await there. So now the entire REST API is following the asynchronous programming model. So this is what we know as async all the way, right? So whenever a request comes in, it's going to use games endpoints that are made for the asynchronous programming model, and also a set of repositories that are using the asynchronous programming model, and also, of course, the asynchronous programming model of the Entity Framework core. So async all the way. Now, before we test this in Postman, one more thing that we can do is actually modify data extensions over here, because remember that if you go a little bit up here, we have this initialize DB method, right, which is the one that we use to run the migrations when the application starts. This also has the capability of running in an asynchronous manner. So all we have to do to enable that is the following. So instead of void, we're going to be returning async task. And for the name of the method, we're going to rename this, and I'll do F2, initialize DB async. And then instead of calling migrate, we're going to be calling await database.migrate async. Okay, so that's the asynchronous version of this method here. So that will make sure that when we invoke the database at the very start of the application startup, we will also do it in an asynchronous way. So let's go back into program.cs, okay, over here, and let's make sure that we also use the await keyword right there before invoking the initialize DB async method. So with that in place, we have everything set up for the asynchronous programming model. So I'll just do Ctrl-J and I'll do .NET run in my GameStore.api directory. And I'm going to go into Postman over here. I'll just make sure that a couple of APIs are working properly. So I'll do our get all games, hit send, and as expected, things are working properly. We just have one game for now, of course. We should actually create a second game. So let's go into post, and in the body, let's see if we can create another game here. So this is going to be Street Fighter 2, and then this is going to be fighting. Okay, let's leave the price as $19.99, that's fine. And then the release date is going to be 1991, and it's February the 1st. And the image array is just going to be that. So let's go ahead and try this post operation. I'll click on send, and then yeah, Street Fighter 2 has been created just fine. And if we go back into the get all, we'll see that it is right there. And so things are looking just fine. All right, so the asynchronous programming model is working just fine in our application. So it is really optimized for not having to do any kind of blocking calls when we have to invoke external services like the database. So that's the end of this model. And in the next model, we will switch gears to another critical topic in REST APIs, which is how to properly secure your .NET REST API. Congratulations, you made it till the end. I really hope this tutorial met your expectations and gave you a good sense of how to get started building REST APIs with the .NET platform. Now, there are several other things that your .NET REST API is still missing to be ready for production. You will want to secure your API to ensure that only allowed clients and users can get access to it. You also want to configure logging, error handling, and many other services that will ensure your API is easy to evolve in the future and that you can quickly troubleshoot any issues. It's also good to understand how to integrate your API with modern client applications and how to identify and authorize users for proper access to the data that's provided by the API. Finally, you should know how to deploy your API to a public cloud service like Microsoft Azure so that your users and client applications can access it from anywhere in the internet. To cover all these topics, I created the Building.NET REST APIs online course, which expands what you saw in this tutorial with dozens of additional topics and resources that will ensure you cover everything needed to build production-ready REST APIs with .NET. If you're interested, please check out the link in the video description to get all the details on this premium course. Thanks for watching, and I'll see you next time.